Can you hear it? Is it okay?
It's only 2 o'clock, so I cannot hear yet. I'm asking him.
So he confirmed that everything can be heard. If he can hear it, everybody can hear it because he's streaming it too with the link. So yeah, just confirm.
Okay, it's fine.
Fine. And now we can just fix the frame a little bit if you want because we have everything else.
I think it's fine.
It's fine.
Because if we go a little bit downward, it will cut
True.
Let's just keep it this way.
Okay. I'm so sorry about the chaos. I think we got it.
Yeah, but then you need to prepare data. Every speaker they need a.
I will be there.
Yeah.
We have this. We got this.
But this is a bit like far away. So probably
I
zoom
have
in
to.
a bit.
Yeah, it's okay. I'll give you all just the speakers and everything else.
Yeah,
You got it.
Okay.
I might be moving around a little bit to change my angles. It's okay?
Yeah.
Okay.
Yeah, maybe you have your food and stuff.
You too. Do you want a cookie? Please take a cookie. We have enough for everyone, please. I mean, for everyone. Yeah. Sorry. Oh, you're still there. Hi. Yes. Yeah. Yes. You want me to ask her to go live? Yes, please. And send me the link. Yeah. Okay. Okay, I'm sending it to you. Tell me if you can see it. Thank you for. I only need Yes. It's live streaming. Yes.
And will you have the recording? Like, can you post later after recording?
Once it's live streamed, it usually stays. So on YouTube.
Recorded later.
Okay, nice.
So if you want to get your photo or recording, probably you need to ask
It's to specifically record yours if you want. So we can ask someone to do it for you.
Yeah. It will be the first talk
Okay.
from every week.
Okay.
Yeah. So I can come later and ask this for link
Record
or...
it. Okay. Yeah. It's all being recorded in the live as well, so you can just take your clip if you want. Yeah.
Yeah, I understand, but I also additionally want your recording.
Sure. Okay. It's all here. Okay.
We don't have to ask them. We cannot say like, okay, this is this. Like we need to get it from them.
I know. I guess they don't know that they need to get it from them. Either way, it's. Which obviously just say yes. I'm plugging into my laptop right now. So we don't need the battery. That's
Hello everyone, welcome to IOSG Outpress Reunion. It's our usual since 2017 where our friends catch up with each other and long-time people are here to meet to help inspire with each other. Yeah, so today the theme is generative world architecture. It's very like an abstract concept. The agenda suggests it's all related to ZK, AI, and crypto, all the buzzwords, buzzwords really. So I think it's inevitable that we have to discuss the potential influence that these important technologies can bring to our industry. So to kick off today's event, I'd love to invite my colleague, Ishani, to give us an overview about her observations on the intersection of crypto and the data. Welcome, Ishani. Hi everyone, thanks a lot for being here. Usually very quickly guys coming here so that you guys will see what happens as well. So I'm Ashani. I'm a principal at IoT Ventures and I lead kind of the consumer direction, research and investment at the fund. So basically that will include the IT, tools, social, market, all of those things. Just a little bit more about IoT Ventures. So the fund was launched in 2017. We've been investing across layer ones, so the infrastructure stack, layer one, layer two, middleware, web tools, security, and data infrastructure as well. And application is something that we're quite interested in as well. So we started off with some wallet, gaming projects and things as well. But we look forward to investing in a whole lot more. So our thesis for the adoption cycle of crypto basically is in three phases so far. We've been through two first phase. The first phase, which basically was your infrastructure pieces, the patch layer one pieces. We saw a lot of the layer ones essentially coming up, the layer two just starting to build. But the layer ones were the ones that were that was capturing most of the value. The second cycle, the one that we recently saw, was where the layer ones were stabilized a little bit more, and we saw some applications then coming in, wallet restructuring, monetizing, and taking some of the value away from the layer ones, as well as layer twos as well, taking the value to layer ones. And reaching the third chapter, the adoption cycle, which potentially can include more and more users, and in fact more users in crypto, is the application cycle. Now that our layer twos are scalability middleware software basically, or our rollups are more production ready. We have actions coming up as well. With that, hopefully we see more exciting applications that are being built, and that could hopefully get more users in the crypto space as well. Here's our investment team at large. If you see any of us here, feel free to come and say hi as well. We'd love to see you here. So, as Queenie mentioned, the high-level punchline of this entire kind of event today is AI, blockchain, all of that powered by ZK Sync. So, three buzzwords, as we said, all packed together, but it has its own merit. So the way we like to think about this is the first part, which is the infrastructure part. The infrastructure part is where we include ZK and blockchain, and we insert that into the AI development tech stack. And what that helps you do is basically include the trust elements of AI development at large, as well as it can introduce privacy, it can introduce properties of essentially with decentralization as well, and verifiable as well. So the first half is where blockchain everything meets AI level, and then the second half is the application pieces. This is where essentially AI makes our applications or blockchain is better as well. They make them smarter, they make them more interactive and intelligent, and efficiently led. The AI development workflow actually comes in like it's one stage process at this point, but you can essentially categorize that into training aspect of it, so when you're developing your AI, the model itself, and then the output aspect of it, where you're essentially just doing computations and verifying whether the compute has completely gone through the model itself. It's been processed by the model. So with that, we actually come across our infrastructure tech stack. This is maybe not the entire holistic map, but it touches most of the major layers out there today. We have the general code, the general ZkSync compute layer, which is talk to you that is video and know. Some of these guys will be attending the panel or they will talk to you today. So if you stick around to that, I think you'll be super easy to access this as well. But they're general. ZKML is just one of the use cases that they provide or that they could enable on their tech stack. Then you have the decentralized ML, and this is kind of an aggressive stage if you're developing in this, where you're trying to essentially train your models on shape, which is slow and expensive and almost infeasible. So no one in the right mind can actually maintain the model where you know, you're spending millions and millions of dollars for an extremely small model to train it on shape. But the company in Generative or TML, what they're trying to introduce is this component of decentralized compute. So essentially, you take a single training process and you scale it across multiple over a network of say GPUs or CPUs or whatever it is. And in that sense, hopefully, it can bring down the cost of this on-chain ML development. And the last one, and the one that I think is more application focused, is the verifiable instance layer. This is where we're seeing some already interesting applications in blockchain. Like Harvard Lab created the Rockefeller bot. I don't know if you guys have had a chance to see that, but it's trying to experiment with it. And then you have myriad AI. But essentially, what the ZK verifiable instance layer basically does is it just verifies whether a computer is actually running the model and you want it to do. And model slash ZKML, which is founded on Excel, and Lambda are essentially building that. What that also introduces us to is this whole concept of a middleware, which is unparalleled. So you can input the outputs of the inference layer of all the compute that happens in here, and they can go into your various applications. So things like identity, technology, and what one is an example of that into your wallet. So for example, as a guardian, I want to use an AI agent as my guardian that can go access to a black swan event or something where it was not an expected behavior on chain on that protocol. So essentially, you have monitoring that can happen, and the wallet can be really smart about that and execute the go practices or execute some transactions for you for the end user without the end user having to be online all the time. And then you have the more common knowledge that is used to obviously for both concept is private tagging in itself, but you can also imagine adding cloud solutions from the internet algebra and data to create more active LP risk management, for example. So this is essentially what the workflow of that would look like, where you have the infra layer, the middleware layer, as well as the smart contract logic. Like, and boys, that moves us into our final and last phase, which is the application side. So on the application side, I think, besides the middleware stuff that we discussed, the wallet, API applications, we think that if anything, the biggest use case is generative content. It can just create content at scale that can enable marketplaces, B2C elements that we've all dreamed of for a long time in the last 10 years, but we haven't really seen that take off. And that can be very interesting because what that can allow you to do is create, we have some examples already of generative art engines that you can create your iterations, and again, with the triggers are probably something you're all familiar with, but also with some like brain activation process. You can create like interesting like AI NPC characters as well, or you can create AI-based campaigns or quests which are actually catered or tailored towards a particular wallet based on their wallet history. So we do have some examples of folks trying something like that now. We have ZKML, which was a challenge for entry-level hackathon project that I'm interested in. There's a person that's integrating that element of startup ecosystem. We have AI Arena, who originally was there when they were trying to build, without the whole inference layer, they were just trying to build AI solutions in that function. But now they're going back and working with some of the infrastructure providers as well to make their AI essentially tunable. And then we have something interesting, which is Generative World, which is a, again, another experiment that has in class where you have a whole community that is being president as well. And then actually that landed up very interestingly to a new concept or a new kind of group of users as well, which is AI artists. So this is AI artists in very specific way. Then you can generalize that as decentralized communities curating an algorithm or an AI model to serve whatever purpose they want it to. So Water is where they curate a particular art algorithm. So you can imagine them trying to curate like a particular wall or a DeFi wall, or you can imagine them curating music, anything of that sort. And then lastly, what it also enables is things like AI-based NFT discovery. So we already have some projects working on that. The AI that they use are not necessarily on-chain so far, or they're not verifiable. But we can also imagine some of these tokenization algorithms going on-chain or being verified on-chain to make sure that the feeds on the social platform that you're receiving are in fact verified and able to use your wallet history, etc. So with that, hopefully we can reduce our user experiences, and like make our applications and our apps more intelligent and interactive. Yeah, thanks a lot, guys. Thanks for
This one works much better. Yeah, so I'd love to invite our first guest speaker today, our old friend Gregor Wilson, co-founder and president at Runtime Verification. He's going to introduce a new product, an exciting one called QEP.
All right, so welcome everybody. I am Vivek Roshu. Let me introduce myself briefly. I am a professor of computer science at UIUC, also the founder and CEO of Runtime Verification. And previously, I was also scientist at NASA. My specialty is the programming languages, mechanics, methods, and compilers, functional languages, scalability. Runtime verification is a technology company. We are probably mostly known for the security auditors who focus on formal verification, but that's really only very little, like 25% of what we do in the company. Most of our resources go to developing the core technology that I will talk a bit about today. In this presentation, Michael wants to present what we call QEP project, data verification project. But we just found that there is another QEP protocol going on. We found it yesterday. Okay. Right, so we may need to change the name. Sorry about that. So we are thinking of changing the name to define square, which is proof of proof. Right, we'll see what is about and why. So what it is, I may say 3D, I apologize, but even I need this 3D, so not 3D. So it's a universal truth system to assure the correctness of remote computing. It builds on ZK technology, but uses ZK technology in a fundamentally unique way that makes it work with all programming languages and all virtual machines and built up. It is also it's universal, verified and verifiable, and also verified. The main, when you think of remote computing, you think of correctness, right? And when you think of, there are two main approaches that are being followed for the various projects. One is verifiable computing, zero knowledge, and the other one is formal verification. And these words live separate lives until now. Verifiable computing, cryptographers, formal verification, formal methods. So we want to unify this in the previous project because both of them have limitations. So verifiable computing can verify that one execution of some program we trust was done, but it cannot verify the correctness with respect to the property of the execution. On the other hand, formal verification can verify that the program is correct with respect to certain properties, but it cannot verify that the remote execution has those properties. Right? So they both are limited from their point. Additionally, both ZK and formal verification currently are implemented using ad hoc and error-prone techniques. They require highly non-trivial re-implementation, custom re-implementation of programming languages or virtual machines as complex mathematical like ZkSync or logical campaign generator. Such large systems are error-prone. If you don't trust, so you have to trust these large systems. Sometimes they have hundreds of thousands of errors. That's not right. So you want to minimize the trust rate. Our 3D or square project is addressing this problem of correctness in both. And also, performance is another issue. What we can models to familiar with performance issues, we believe that performance can help. The core innovation of our 3D is the following. So if you go home with something from application, you should be amazing. It reduces the problem of verifying a computational claim. And a computational claim can be a verifiable computing kind of claim, or execution claim, or a property correctness claim. It reduces the problem of verifying a computational claim to verifying mathematical proof. And we verify the mathematical proof using a universal proof checker. And that universal proof checker is implemented as a massive parallel ZkSync was not possible. Alright, so that's the main idea. And this gives us universality, works with all languages and all virtual machines, and it is verified construction and it is verifiable and also verified. We solve two problems at the same time. First, it generates correctness proof, ZK proof, nothing used, and those can be used programmatically, including for formal verification. Remember, formal execution, or formal verification is a property. All of this will be done in ZK proofs that can be stored on the blockchain and checked programmatically. For example, a bridge may check if the RT20 compliant with the protocol. So the letting volume protocol can programmatically check the RT20 compliant. So that's one. And second, that it is universal in the language of virtual machine. So essentially, we can plug and play the programming language. In particular, that means that you don't have to modify the program. You take programs and execute them as are and replicate this without having to modify the tools every now and then. So what makes this work? How can this work? How can it be so general and efficient and universal? Well, so there is a convergence of three critical technologies that come together here. One is the K framework that we spent more than 20 years developing data verification in my level university as well. And this gives the QED, our QED, universality, the universality feature. Because you can, in the K framework, you can define the programming language once and for all, and then the K framework gives you all the tools for that, including execution engines, form of verification, volume execution, all the tools that you need for your use. The second component is matching logic. Matching logic is the minimal logic. When I say minimal, I mean really minimal. Like a proof checker of matching logic has 200 lines of code. Okay. That's how important it is. And with this logic, you can check mathematical proofs of any properties of any program in any programming language. And that's true. I know it's a small thing. It has been designed for that purpose. And the third component is basically cryptography, so we can have massively parallel class. Let me show you a picture that the architecture of the project, which is possible because of the three components that I mentioned. So this is how it works. So the K framework, as I said, takes the programming language into. A programming language in this framework is a mathematical theory. We call formal semantics. Formal semantics of EDF, formal semantics of Python, or of Rust, Watson, C, Java, doesn't matter. There is a programming language at equal. And K has an arsenal of tools, execution engines, interpreters, compilers, word execution engines, fully fledged programming verifiers. And now, these tools can take computational claims as input and give you mathematical proof, traditional mathematical proof, not cryptographic. Claims can be execution claims, like Alice book something like that, or they can be property correctness claims, like, hey, that is compliant with the correctly articulated code. Any claims like that, they are handled by the appropriate free tools, and you get a mathematical proof. Right? So notice the universality, how we capture with mathematical proofs both execution and property correctness under the same umbrella. The problem with mathematical proofs, very detailed mathematical proofs, is that they are huge. They can be huge. So how can we compress them? How about this? Instead of compressing them or sending them as R, how about checking them locally with the methodology proof checker, which is now implemented in the. And what you get a cryptographic proof in the end, you see cryptographic proof of truth. You have a cryptographic proof of a mathematical proof. And now I use that cryptographic proof as a certificate of correctness for the claim language. Either the verifiable certificate claim or execution claim or a trusted correctness. So that's the main idea. And I know I don't have a lot of time, but I like to emphasize instead of going to other slides, I like to emphasize a bit the universality of this picture. Imagine that you plug EVM and you only look at execution claims. Forget the property correctness. Then you get a certificate, then I get EVM. No difference. Or suppose if you plug, there is 5 semantics there. And you also look just execution. Then you get what is zero. For Cairo, software. You just the same pipeline, the same general architecture. But you can also do formal verification. And you can also do other elements. There's a power. Right? And with this, I would like to invite you to collaborate. We'd like to form partnerships, integrations of this architecture with AI/ML projects in this blockchain project. So if you would like to have ZK proof for your project and you use a particular programming language or a particular library that require you to develop some ZK proof, you come to us as well. We like to be offered the ZK proof for project. We have 2 or 3 open to all projects. Thank you.
Thank you so much. Thanks for bringing trustlessness into and please explore us synergies with it. As we all know, that blockchain is all about data. So we'll have Oma, the co-founder and the CEO at Ingolana, to talk about the ZK data.
The topic is the data center, and I will start with four ways to do this. When we start with meta that's what I'm talking about. Then we disengage, basically the presentation, significant amount of the so basically, there are 4 things that come to mind with start off with decentralization. Okay, computer, but we don't know really. So next year, I will try first lots of population use cases, show them better. Also talk a bit about theory of age, push water, another question. Most of the topics are kind of open anyway, so also regarding the topics that we discussed later. Finally, I think a lot of example would be coming from the area of electrification and how to do execution. I think the learning in this okay. So let's talk about use cases. Let's take again this. So it's kind of like short way. So first of all, there is the one, maybe a Python examples. So actually, synthetically consume the data to call CKML consensus and such everywhere. It's always same to Python. There's also tools, so we all know this how we can then take forward in this session. Now, there's also computation and privacy preserving part. So how this works, the users actually are participating actively in one project, initiating the protocol. So I think this will happen very soon. And assuming this happens, so mostly we can imagine how this data center can be, I can now participate and play also privacy preserving applications all the way from smart contracts with privacy to identity. You can also think it's very kind of like easy transition to be part of the marketplace, centralization, centralized approval network, and so on. So standalone applications, so there's not this related to privacy, but gaming, I think, multiple games can be disrupted quite nicely, like the city data center actually replace gaming data center, right? Like replace Blizzard or something, and then gives you like trustless computation, so there are like few benefits here on what can happen with this kind of like application. And then this example of private AI. So this is full of open encryption. Basically, you want to send an encrypted prompt, right? An example, you want to send an encrypted prompt, get back an encrypted answer, and the machine learning model was actually running on the cybertext. Okay, so that's very interesting. I go into a specific example for that the last part of this talk. Now, let's dive deeper into what it actually means to say ZK data set. So there are various aspects to what a data set actually means. Okay, so obviously compute and memory, and also some kind of like logistics, right, and cooling and so on. Scale is super important, right? Again, if you want a lot of ZK cooling power, you can imagine that you need quite a lot of all the rest. And I want to focus on what I think is right now the more interesting part, or what's going to be harder to achieve, which is the compute. Okay, so let's break it down. Okay, so one step deep. Let's imagine it as just many ZK servers that are stacked together. It's kind of like one base component. And the way that we imagine it is that these ZK servers are complex standalone. So very standard. Your average dev, one pizza server, no connection between the servers, keeping it very clean. And the only purpose of the ZK server is actually to host as much ZK cards as possible. Okay, so ZK card, what does it mean? So ZK card, again, you want something very standard and replaceable if you want. And basically, the way that we can think about it is that there's some kind of like acceleration code on the GPU, we call Z is how we call the basic, right? Because the one acceleration. And then like peripherals and memory and so on, right? So my company, by the way, is in charge only of this small part, right? This entire concept. Okay, so we should operate a ZK data center, and this again, it's not like an open question. So I'm gonna try to compare two options, and then we'll see if there are others. Okay. So there are a few points of comparison. One in terms of scale, and the second one is in terms of utility. Okay, what I mean by utility in a ZK data center, you might expect some examples. You might expect to kind of like have this communication interaction with ZK data center. You send something, that's something different. It's like security, I don't know, maybe kind of like a weak thing, but maybe you do have kind of like level of security you need to maintain, and reliability and uptime and so on. Do you care if the ZK data center is up 99% of the time or 99.9%? Okay. So the two potential actors that comparing it, one is miners. Okay, so miners, they know how to do it, they know how to scale, right? They know how to do real estate, they know how to do electricity, all of that. So they definitely win when it comes to scale. The other type I know of factor is what I call blockchain infrastructure. So think about staking services, validators, even exchanges, right? Like ZK, like blockchain clouds. And here, when it comes to scaling, they can also do the job, but they're not excelling it. Okay. On the other hand, when it comes to utility, these are the services that are also security, wallet, for example, and they know a lot of things about how to actually communicate and how to users. Finally, when it comes to uptime, so this is, it's just like the level of opinion. So the miners, they can handle downtime, that's fine, it's fine, it's not a mistake. While the blockchain infrastructure has to maintain a very strong, very high level of reliability. Okay, there might be someone else. Okay, so there are a few other options. Could be an additional way like an AI data center. That could be others as well. I'm using the GitHub, and you'll see in a moment why. Okay, so now I want to talk about this specific example. Okay, so this is the most technical part of this talk, so bear with me. First, when I'm talking about private inference of LLM, let's kind of like try to imagine what I mean. Okay, so this is kind of like the protocol you can see. You have the user, you have the ZK data center. Now the user is generating keys, the user is generating the prompt, the user is sending an encrypted prompt after encryption to the ZK data center. The ZK data center doing all of the work, the machinery work, inference over the encryption, and send it back. Okay, send it back to the user, which decrypts. Okay. So let's see what happens when we apply this kind of like protocol on something like the ZK data center. So let's start with some assumptions, okay? And of course, I'm taking like post-based assumptions just to be on the safe side. So first, when it comes to user experience, okay, actually we want something to be reliable enough or working, something to not take forever. So 1 token per second, the token is like a word. Sounds like something reasonable, and we think not long ago this was also the case for systems like OpenAI. So now it's way better than that, but basically imagine that, I don't know, you're a doctor, you want to send something to this like LLM about whatever you want, so combination for this. That's something that can be very contextual. Another thing is that the number of arithmetic operations needed for this entire computation, like the ZK data center, is kind of like equal to the number of parameters in the model. Okay? So again, rough estimation, but let's just assume this is the case. Now let's connect it also to fully automated encryption. So now every arithmetic operation can basically be mapped to an arithmetic operation in one scheme called PFG. So this is like one flavor of fully automated encryption. Okay, and every arithmetic operation in PFG requires a single programmable bootstrap. So this is like the heavy lifting. This is where the actual hard work is happening. This is of course what it is. It's okay. Nice. Now, when we go to the state of the art, so remember the diagram of the ZK data center. So this is the ZK file in that case. It's like an FPGA, and basically what it gets us is that one PBS takes every, you can do one PBS every 35 microseconds. Okay. Now, let's apply to a real world use case. I'm going to use GitHub Copilot. Why not use GitHub Copilot? So you can read it. If you look closely, they basically should pay us. I mean, we give them information for free all the time. They take everything. Okay. So why not GitHub Copilot? Just for background, it's this LLM where I basically send like I ask for a generation function and using that virtual function and whatever program. Okay. So this is something again, we can talk about imagine how we are able to be extremely super fast. Okay. In terms of parameters, it has 12 billion parameters, and also when you do ChatGPT 3, which is like I think 30 next parameters just for comparison. Okay. So with one kind of like accelerator and one ZK, it can take us 5 days to get one token, right? So that's the value that's not acceptable. Let's now make a few assumptions on the ZK data center. I'll come back a little bit later. So first ZK card, okay, so let's assume we're using not this FTP, but upgrading it into a CPU, okay? So we can assume the frequency is now 1 giga, which was before, I don't think the frequency was 200 megahertz. And in terms of available resources, we can go 8x. And that's based on kind of like our idea of the CPU, very kind of like, again, worst case assumption. Okay, so it's like 4x. In terms of ZK data center, so we could go into like a medium-sized data center. Let's assume we have 10K ZK cloud, okay, in our data center. And another two very important assumptions are that all of the ZK clouds can be fully utilized and can be run in parallel and be again busy all the time. Okay, so that's actually the case in this example. I cannot say that it's trivial, but in this specific example, I'll show you because after all, it's very reasonable assumption to make because you can actually you can probably think about it, like it's a machine learning like a neural network, so there's like a lot of parallelism that you can take advantage of, right? So that's kind of like the way that you can take advantage of parallelism and basically get all these stuff to be easy. Now, if we plug these numbers, what we get is that for GitHub Copilot, we actually can manage to have 1 token per second. And ChatGPT takes it's a bit slower, still probably accelerated for vector and so on, but yeah. Which means that this ZK data center, first conclusion, can work not only for ZK but also for real encryption, can actually provide very reasonable results, even not today, but hopefully something that you can think about, reason about, and work with state-of-the-art element. And yeah, that's basically all I have to say. So if I have time for questions, we'll be happy to take some. Otherwise, yeah. Any questions? Okay, thank you.
Next, we have the ZKML panel. Could I ask all the panelists to please come on stage? Hey guys, thanks a lot for being here. Maybe we can start by just a quick round of introductions. Yeah, maybe Jason, you can start.
Sure. Jason Morton worked on Ezekiel, which is a compiler that turns what you write in Python and turns it to a proof and then you would verify. Hey, I'm Z. I'm one of the co-founders of Axiom. We're a ZK coprocessor for Ethereum that lets smart contracts trustlessly access any historic on-chain data point and do verified compute on top of it. We just launched mainnet 2 weeks ago, so you can try us out.
Hey, I'm Fran, founder of Visa. We're building our platform for highly scalable, verifiable machine learning.
Hey everyone, I'm Daniel from Modulus Labs, and we're working on a specialized ZK prover just for AI operations, so it's super fast. Blazingly fast.
Hey, so I'm DC Builder. I'm a research engineer at WorldCoin, and we're building a privacy-preserving protocol.
Okay, cool.
Do one more. Yeah, let's do one more.
Alright, thanks a lot, guys. So maybe we can start off with a lightweight version of just what is ZKML for the audience to get acquainted with that, and then we can go into with questions specific to everyone's going. Jason, you want to go first?
Yeah, so you think about a digital signature. Digital signature has a setup where we decide an algorithm to run at the ECDSA, and you take a public input and a private input, which is your key. You run the algorithm, you receive an output, which is the signature, that can then be verified on-chain with everyone else. The idea of ZK in general is to replace that signature algorithm in the middle with an arbitrary program. The idea of ZKML is to replace it in particular with a machine learning program.
Yeah, I'll just take the other side of it. We're exactly the same thing as Jason mentioned, but the way we like to describe it to folks who are implementing it into their services is we give you the power to surrender your secret control over your algorithms, which is a very scary but kind of sexy way of looking at it. But basically, the same thing as Jason.
Okay, so with that kind of background, some of you guys are building infrastructure, some of you are building more like application-specific infra. So maybe we can start by talking about like just what are the obstacles when you guys are building these specialized like provers for AI models or like toolkits, for developing essentially like bringing AI on chain.
One of the biggest obstacles is kind of giving people the right abstractions and the right set of tools. I often like to say that as software developers, it's like if you were a sculptor and you just delivered to your client a giant block of metal, it's like, hey, you can do anything you want with this block of metal. Therefore, it is the best sculpture in the world. Obviously, we're not going to pay you. So, similarly, our job is to not give you a block of metal, but to figure out what abstractions are good ones to develop with. And I think we still struggle with that every day. That's probably the single hard problem.
Yeah, I think what we're working on is allowing users to deploy computations, not just machine learning computations, but any computations on chain as part of their actual production applications. So I think a couple of challenges we're tackling is how do you get verified data inputs to machine learning models? If your computation is verified, it's not that meaningful unless inputs are also verified.
For me, the biggest obstacle I would say is tuning, because here we are working between ZK and ML, and many ML people doesn't know what's ZK, and ZK people doesn't know what's ML. So how we fill the gap? So building good abstractions with good tooling is something that is heavily necessary to people that know ZK can interact with ML models easily and to into applications, and for many people to doesn't have the necessary need to know what's okay to do verifiable inference or provenance of the names.
Yeah, I think so. The background of Modulus is we ended up building one of the first ever ZKML projects, and then we're like, that was kind of silly. Let's see if we can do a bit better. And we ended up making the model much larger. Build our second one called Dataverse and Security, right now. And what we realized in building these two projects very quickly is that if either, and actually the third one coming up next week, were deployed at scale, Modulus would go very quickly. Yes, it's really hard to do, and that's, I think, a big part of it. But once you get on the other side of it, and you have these AI models, which are already very computationally intense, and you slap on a ZK prover on top, it becomes pretty cost prohibitive. And because of that, the design space is extremely limited. And so we're really motivated to make sure that as the tooling gets better, as the data gets better, once you get to the other side and you're starting to do these massive computations, that the costs are reasonable as well. And that's why we focus so much on speed. It's faster, it's cheaper, in cases.
So I think everything is inside. So I'll just do a little recap. So most of the costs or most of the problems that are occurring in ZKML, there's different vectors, right? There's the performance cost side of things. Then there's the abstraction side of things, where some people do not know how to tackle the problem or what it's used for. Then there's the tooling, right? So there's how as a developer can I tap into creating circuits out of my machine learning computations. And then it's just general education about how or what even ZKML is. So there's about it.
Okay, a little bit of improv over here, but the questions to DC Builder, will WorldCoin actually use any of the tools that is being built by the folks here, or will you do it yourself?
Hello? Yeah, okay. So currently we're not going to build any of the tooling ourselves. We have a lot of things to update already, but we are exploring avenues, for example, with modules on how to essentially build a ZK prover that would be able to run on a mobile phone for proving ML inference. It's a smaller-ish model in the sense that when we create this sort of embedding that represents the randomness encoded inside of human iris, it's a fairly small model. And the problem that we're sort of facing is that if we want to make someone be able to run that model locally on their client instead of running it inside of this hardware device, it would be really computationally constrained, right? Because a mobile phone has very low computational power, and if you want to run a ZK prover and then on top of that, run a ZK prover of a big machine learning model, it's very expensive. So we're working with several people, and especially with Modulus, on sort of trying to figure out how to do a to an ML model and a computation constrained model.
Yeah, and then like another quick question to folks in the group that are building the infrastructure, both points being the application side. What are some of the kind of early use cases you've already seen that have been built in the community, or early use cases that you think is going to kind of kickstart the application side of the ZKML projects?
I think in some senses we're still in the kind of hobby phase. If you think of this as like a PC, the banking mainframe is kind of 5 minutes, private networks, that kind of stuff that we've already seen, rollups. We're still sort of at the hobby side or exploration. That said, we're seeing DeFi, generative stuff, like this conference, like generative stuff, classifiers, oracles of various kinds, and a lot of just also weird applications that you wouldn't, you wouldn't necessarily think about. Okay, so we have a demo now, and it's like where you just karaoke basically. You sing, and then it judges you. And this is the kind of weird example that's fun to do in order to sort of test out the crypto system and smoke things. I think we're still really at that phase. I think the potential for applications is tremendous, but putting a lot of money behind things right now is probably too early. So let's have fun for at least a few more months until we're sure it works.
Yeah, I would echo Jason's point that it's real. A lot of the applications we're seeing, maybe you would call it machine learning, I don't call it averaging numbers. It's hard to get a system that reads data on chain, averages the numbers, and puts it back on chain already. So I think that's kind of the stage we're at.
For myself, I think most of the early demand of use cases comes from how to avoid adding more complexity to the smart contracts or DeFi protocols, for example, by running this kind of complex behaviors of chain and then just using the production. For example, we can think of under-capitalized loans or how to do business scoring for DeFi protocols, so people almost money with the money inside pools. These are like some kind of early possible use cases that's like not to replace or automate the whole protocol, but more as an assistance to people making these decisions. And for the non-crypto use cases, also I think there is a good use case in healthcare, a good opportunity there on how to provide this provenance of the inference of the model, for example, for using myriad for cancer risk assessment or any other use cases to provide like a more transparent way for using ML into this industry, for example.
Yeah, I'll echo all of that and just say that the singing app is actually super cool. I tried it last night. I think it's called, is it cryptoidols.net? Yeah, it's really cute. Yeah, definitely echo the experimental phase of things. That's all the things that we built so far. I will say there's definitely, maybe to Fran's earlier point, like the AI competency is pretty new in crypto. Right? Like most folks walking around here aren't like using the PyTorch and training massive models yet. But what's exciting about being kind of at the leading edge here is we are very rapidly adding more tools into the toolbox for addressing your smart contracts. Right? And so as a point of reference, I would say by the end of the year, Modulus alone will be doing millions of AI proofs every single month for actual customers, right? Which is very exciting for us. I have no idea if that's economically sustainable for us, which is my way of saying it's not. But in some sense, we're excited that there is already demand so early for something that is so nascent. And it really kind of lights a fire under our behinds for getting the prover tech to be much more efficient.
Again, everyone echoes everybody else's opinion. But yeah, I would just add to that. For us at WorldCoin, like we have one or two use cases where it would make sense to leverage ZKML. And the technology is like slowly or like almost like pretty well catching up with the requirements or what it needs for doing things like that. So I say like it's early, but there's already like early signs of the technology actually being useful. And maybe like
quantity or to have several production applications that people use day to day.
That makes sense. Thanks a lot. I'm going to try the cryptography after this, after today. Yeah. I guess I'm curious, like for Axiom side, because you guys are doing general computation as well, not just DK, but what can we do with Axiom when plugged into one of the folks building ZK and stuff here?
Yeah, so we're actually working on a system to self-serve the general computation. But right now, what Axiom lets you do self-serve on-chain is access 64 pieces of any block header, account, or storage log in the history of Ethereum back to Genesis. So what you can do with that plus ZKML is whatever you can do kind of machine learning algorithm with 64 different inputs. Maybe a historic price series, historic volatility series, or anything you can really have. And so obviously, we can't be running a very complex machine learning algorithm with 64 input data points. So we're pretty interested in things like linear regression, logistic regression, or even numerical functions. So we have spent our open source program recently implement all of these in fixed point arithmetic, which is necessary for ZK. So if you want to use any of those functions, you can check out their fully open source software.
And maybe like a follow-up question to everyone here on the panel, like, if I'm a developer building and trying to build something on any of the projects here, do I need to be committed to a particular chain or a particular
We focus on either compatible, so if your chain can do Solidity 8.17 or higher, and it has the pairing opcode, you're okay. If it's anything else, do it verifiable. Yeah, we have the same limitation, and in addition, we read from the data structures underlying BN, so we require that your chain or rollup is actually BN correct. So that would include Arbitrum, Optimism, and Polygon, but not ZkSync or Polygon.
Hello. In our case, it's also EVM compatibility. So we support like everything that is supporting by the verifier, start verifiable that happens solidity, can be the Polygon and you take to the rest of these sequences.
And I guess like also curious, like the stars, what kind of like prover algorithms are you using or how?
So we're using Gelato in the back end. Yeah, same here. So we're using Gelato with the KZG backend. And maybe just one thing to say about peer systems, although maybe there's a point of view in the space that it's very hard to switch between peer systems, as things are progressing and peer systems are getting more modular, I think you'll actually see teams switch between Starks and Snarks as the new state of the art progresses. We just saw ZkSync switch from Snarks to Starks yesterday, and we're going to see more of this going on as teams move to what's the hottest thing.
For this we are focused at the beginning on stars. So we are doing everything using Starware's tile language. So there is this new technology to start, but it's not, we don't focus on a single technology. We are like a product. We serve like a general purpose verifiable machine learning. So down the line we'll be supporting for different purposes like stars as well, different proof systems.
Yeah, this is very exciting for me. This is thinking about this all day long now. So, our perspective is probably pretty similar in the sense that in some way it doesn't really matter. Like once you get good enough, it gets abstracted away from the application. Yeah. It's just about getting the unit economics that can support the workload, and you really need to empower your service, whether that moves needle enough or not for the ultimate customer in this case. Whoever's at the top of the spigot. With that being said, in our case, after we built a couple proof of concepts and got totally scared by our financial statements at the end of the month, we ended up benchmarking all the popular proving systems that are used today. And kind of the insight that we had was not only are the performances like really different across the different proving systems for these AI primitives, but also each proving system was good at a specific part of the job, which is actually kind of bizarre, right? And it comes from the fact that these proving systems are really built for VM operations, memory registries, all the things that we want to do. It needs to kind of support those arbitrary operations. But AI problem statements are actually much more specific. And in fact, the structure of the compute is super repetitive, highly structured, and these are architectural features that really represent a down selection from all possible mathematical operations that proving systems generally need to support. And so, the kind of conceptual, milestone for us is if we can build a proving system which acknowledges the structure of the compute going into that process, then we should be able to get much better efficiency. And so that's kind of a big part of what's motivating our own work in, Frankenstein monster proving system, which is just built for AI.
Fine. Anything opinion on that?
We're most likely going to use which is the proving system that Modules is using. In terms of our proving systems, we're using DOS 16 because that's what Semaphore uses.
Good. If you guys are more interested in learning more about the proving systems and how their implications in becoming the ZKML, I think one of the steps you guys published the white paper called Cost of Intelligence, which is pretty interesting to read as well. Yeah, and I think a couple of final steps. What are the biggest bottlenecks when building these the whole infrastructure stack itself? Are we gonna financials is one thing that Daniel mentioned, but then do we also think latency issues, performance, throughputs, all of that stuff? What is gonna be the one biggest kind of bottleneck for applications or developers when they start using it, assuming all the abstractions are in place?
Yeah, sure. I have to say that I think one of the themes of ZK is that progress is winning at the schedule, and things are being really fast. And Google is about 10,000 times faster than it was in September. So, instead of saying you can just wait for elements to go away and someone will solve it for you eventually, or we have the same strategy. If the research should happen, and before it makes sense. So, to me, the biggest bottleneck is always applications, and actually more than anything else is that. However, I think in the short term, there's definitely some computational constraints and some high bills, but I don't think that's going to last because the fundamental nature of proofs is that you can do so math and make it cheaper and faster. So we all like to do math, and so eventually those things will get fixed.
Yeah, I would echo Jason's point that proof systems are going to solve a lot of these performance issues. I think one thing we've learned from going to production is that the executing a full security story for a ZK-powered application is really pretty challenging. And more than that, once you've done it, demonstrating to your user the full transparent sort of chain of security from your code to your deployed on-chain verifier to verifying that the bytecode actually matches something that's verified. That's actually a pretty big burden for developers today, and it's something we're looking to address.
The biggest challenge is, apart from the performance, technical issues, whether it's more like the demand, developer experience, and projects understanding the value of the ZKML interface. That was the purpose of it, just making ZKML just ML for production, where just the ZK part is like a requirement for provenance of production systems in ML. So this is like one of the keys to bringing mass adoption to ZKML, as well as providing a good abstraction for users. So they don't need to care about the ZK part. You just do AI and that's it. And we provide like highly scalable architecture for them to really do it.
Yeah, I think this panel kind of says it all, right? Like we have 4 infra folks up here and then 1 application which I think is just the ratio probably across crypto. Maybe we're actually doing better than crypto as an industry in ZKML, which is a bit concerning. I mean, we're all just going to use each other's stuff, but somebody has to use all of our stuff at some point. So yeah, I guess traditionally modulus, we kind of realized for ourselves that this is a capability. It's like, okay, it's really hard, it's really expensive, so let's go and build some stuff ourselves. Understand why it's hard, understand why it's expensive. And the good news is we're not doing that alone. Like these are absolutely brilliant human beings all working on this problem statement. So as Jason mentioned, I think like tomorrow will be better than it is today. But unlike the technical challenge of making this developer experience and improving costs better, the application challenge is hyper-relevant. It's like a multi-dimensional issue. You discover kind of the customer's willingness to pay and things like that. And we're very thankful for our friend DC and WorldCoin. But the future of ZKML cannot just look like our friend DC at WorldCoin. Right? It's got to look like thousands of this fan just everywhere.
We can take care of like the users. We have like about 2 million registered users from already, which is our price building customer protocol. So if people like want to have this sort of better user experience in the sense that they only get registered once, and whenever like we change the iris code generation model, or we add a new feature where ZKML might be used, then users, instead of having to go to this physical place with the physical device, they can just download a new model, download the proof report, and just recompute the proof of the generation if they have the input from the first time they set up. And yeah, like we're gonna have more users as time goes, right? More people on board with the protocol, and that will create demand for ZKML. But as Daniel has said, there needs to be more use cases and more people coming into the space and leveraging the product.
So I think we all agree that adoption, ecosystem development, more developers are something that all of these are going to need in the future, and crypto as an industry as well. I'm kind of curious, like converting ML engineers to come and produce stuff and use ZKML projects sounds like a very different type of task. Like we've been trying to convert like folks to get into crypto, like developers to come and like build on crypto itself. That's been challenging enough. But doing something that's so niche is also going to be challenging. Do you guys have any strategies for the market? Ideas about ecosystem development that you guys want to share maybe?
Another way to put this, I think, is that it's actually extremely difficult to convey what a zero-knowledge proof is to a sophisticated person who doesn't live with asymmetric cryptography and its properties every day. You tell them like, oh, it's like a generalized, it's a programmable signature. Like, great, like, is it like an arm? It's really hard. I mean, even technologies like private equity, like we see, like private equity people, and they don't process what it is that we're even talking about, like what the epistemology of it is. To me, that's one of the biggest questions and challenges for if we can ever expand OFR, the crypto space that understands this property. It's kind of yeah, I would say I felt the same as Jason until ChatGPT came out. And then I felt like there was a step to transition in how easy it was to convince someone, not in crypto, that being able to prove computation or prove execution of the model was valuable. Basically, people are very scared of the scenario where their grandmother gets a big phone call and transfers all their money to a scam. So I think they don't quite understand what ZK is and how ZK would solve that, but they do understand, I think, for the first time that having some notion of trust and verifiable provenance is valuable. I think that's true for both ZKML and the whole space.
For adoption in ML, we need to first convince engineers that are actually building ML. So most probably first users, people using the frameworks that we are building, the that we are building, and are going to be ML engineers or data scientists. So we need to provide or keep the tools that they are using daily for building models compatible with the tech that we are building today. This means like they build models in Python, we need to be compatible on how to use these models that they use for training Python, to having verifiable inferences. So we need to abstract all of this heavy load to convert like these models trained into ZK circuits that are like efficient and faster to execute, plus this provenance layer. But not only in terms of usability for the non-engineers, but also how do you put these models in production and how do people use these models usually to consume models such as API calls that you do to an endpoint, they consume send the data, they get output, you need to provide similar experiences, how do you monitor models, how do they manage the deployment of models, the whole life cycle of these models. So we need to provide similar solution, but more related to adding this provenance layer on top for ZKML.
Yeah, I couldn't agree more. I mean, maybe just add like a qualitative layer to it as well. I think these two are math professors for crypto. Fran was an ML, head of ML at Vitas, right? DC and I were just children before this. We're still children. We fight with our facial hair. The point being that I think if the question is how do we get people to do ZKML, we seem to be doing okay insofar as I think the kind of ethos of all this crypto, which seems to be very attractive everywhere else, is pretty attractive at ZKML as well, especially the quality of verifiable compute and what that can mean for trust in the future. It's our job to figure out how to distill that into a sales motion that makes sense for as many people as possible and those people find as valuable as possible. And I think everything that's been mentioned is absolutely in motion towards that. And actually, point, like talk about human touch points, doesn't get much more intimate than your iris. And I think when you feel the impact of having your iris data safely secure on your phone, hopefully that will be very influential. Move the needle in the right way.
So I think I'd add something on top of E's place where I'd like to say like if there's humans that care about the sort of trust of provenance from the original input to the original data, quote unquote, I think like if users start demanding these as like built-in features into every single service that they use, especially like from the machine learning context, it's going to create pressure for the service providers that leverage it, right? So if even like developers, for example, require some proof of provenance or like some proof of computation from the APIs and servers we consume, because the sort of plethora of models that exist out there, some are more performant than others, and all of these API providers may lie about which output they provide, right? Like I can say that, oh, I'm running GPT-4, but in the background in the server I run GPT 3.5, and I just get like easier output, I just provide you that, and I profit on the infrastructure arbitrage. The user may as well just demand that computation that they actually use some model, even some hidden weights, but that is committed to be the same model of the claim that they're running. So if either developers or users do demand that, hey, I really want this proof of computation or something akin to that, where users sort of understand that, oh, I want this to be something I can trust, to be solid for like that, then I think that's great.
We were hoping that it can actually solve like people feel that the intimate use cases like healthcare data or like your iris, for example, will actually convert them into adopting ZKML, which is kind of a different approach to larger crypto, right? Because you want to make everything public, you're very detached from your real life. Whereas the ZKML, you're actually enabling things that are actually the opposite of what normally would be used in crypto. So I think that's like a different and interesting kind of approach to it as well. Yeah. And I guess like one last question. I know everyone here is working on inferences mostly, but how do we feel about training data on chain? There's some projects doing that, and do we think we would one day kind of also expand into providing those kind of services as well? Maybe Jason can start with you.
I have a couple of comments about training. So right now, of course, the methods we're using right now to for training, somewhat small changes in the system might make them suitable for training, but to their ethic, you'll be able to do that. I think one of the questions you have to ask yourself when you're doing some kind of distributed training, always, why are we doing it, right? So if you have a bunch of big GPU servers sitting in a rack, they're all interconnect, they're very well suited to the task. You spread that over a lot of people, and do this high overhead thing. Now you take a model that costs $1 million or $10 million to train. We're talking about it costs $100 million or $1 billion to train. And so you have to have a very good reason to spend that money. I'm not saying that we don't, but maybe we're at a point where everything gets locked down. It's the only way to have open source LLM that's powerful and that's going to be justifiable. But yeah, I think that's the big question. Is like, why does it economically make sense? Not is it technically possible?
Yeah, to echo Jason's point that training large models is probably very challenging today. Actually, the same participant in our open source program who wrote the sign function in ZK also wrote training for random forest, logistic regression, and linear regression. So I think that is possible and eventually useful on chain today. Last thing to say about distributed training for large LLMs is that, as Jason mentioned, the bottleneck is this network connectivity. Typically, you're training in a single data center where the network cards are so good you can treat 100 or 1,000 GPUs as one GPU. So there's some interesting work out of Stanford behind this company called Together, where they study how you can do distributed training with degraded network connections. So it's already very challenging to do this, where you trust every computer, they're just in different data centers. And so they haven't layered on incentives yet, but if you are curious about state of the art on just fully trusted distributed training, you can check out together.xyz.
Well, in terms of training, I think in terms of performance on whole mass computers, it's close to the CK ways that seem expensive and not worth it. But more simple models like registry versions or linear versions, maybe it's possible to train on chain. So like when you are doing CK training, maybe if you are doing a distributed system, you need to have a totally linkage right. You need to know that you are distributing the training. But for example, these past days, we participated in a hackathon on the CK week, where we provide our open source framework for doing ZKML using Caro, and some people use some open source projects like build a linear regression train on chain using our framework. It was something that was not intended for a framework because it's only inference oriented, but it seems a bit, so maybe something exploratory, experimental is possible, but I don't think that for the scale is feasible.
Sure, yeah. I guess the last thing I can add potentially is why. Why? It's so much work to just do cryptographic operations. Like, you don't have to, but please don't. Right? Like, you pay for it in money and time, and I'm not sure it makes you more appealing to your preferred sex anyways. So, like, why even put in the effort like that? And I think with inference, the utility is pretty clear, which is like somebody might just swap out one result for a different one. And if you really depend on the kind of integrity of that result, that can be a problem. So, the cost of unfaithful ML, if you will. With training, people are like, data IP is scary, we're going to sue stable diffusion or whatever. I think, that lawsuit goes through, yeah, super interesting. And like ZKML is just a technique. There are lots of other cryptographic techniques, Together is an exceptional example, right? That might make training more cryptographically interesting, let's say. But in the meantime, we have our hands full with inference. Although I can't wait for the excuse to get to training as well. Yeah, I don't think that I really get to that.
We have like last couple of minutes, I think. Maybe we can ask anyone from the audience if they have any questions to any of the panelists.
So, doing work in formal verification and correctness, and I cannot resist from asking the question. If a ZKML can use a CK proof or something, what does that mean? Can I trust it fully? Because there are so many things that can go wrong. For example, the algorithm integrated in C, and C is a monster. It can have undefined behaviors, it can have overflow, it can have lots of things that can go wrong because of the programming language. And I wonder, what does ZK even mean for me? And is it correct? Or correct with respect to what?
it's a very philosophical question, so I wish I could answer it. But one thing that I like to think about is this problem in general that I was talking about, generally communicating the value of verifiable compute, right? People say, well, instead of trusting you, I'm trusting your energy volume, right? And like, how do we ever get over that? I think formal verification is one of the ways. I think another way is just well-tested open source libraries that have a ton of eyes on them and that are maintained by the community. Trust like that is built over time. And what it means is built over time and not being hacked. And it's a long slog.
I don't know, like there's sort of a distinction between what happens if everything is done correctly, in which case the answer is very simple. It proves up to cryptographic guarantee that some function that is abstractly defined as, say, a neural network was correctly executed. And as Jason mentioned, there's a huge portion of what if not everything was done correctly? What if there's some error in a translation and a compiler? What if there's some error in the actual proof system? And I think that's probably closer to the traditional formal verification.
I would like to use here the answer that I think is open source. So do trust more like an open source library that they do maintaining, or a big tech company like Google or Meta. So if you have your library is not working properly, you have the opportunity there to solve it. You can always like check that it's working now, or if not, we can open new issues. So that's another important point that we need to, as we progress into the ecosystem, also like to grow in it like fully open source instead of trying to be closed source. Like big companies are doing, and there's nothing different there.
Yeah, I think the big funny thing about so much of how much we care about trustlessness is that fundamentally it still simplifies the end consumer into a trust motion. Right? As in, like, I don't know, like I like Uniswap, I trust Uniswap because I know it's like fully on chain and everyone can audit it, and yada yada yada. So at the end of the day, I trust it more, right? And so, I think I like the way you put it earlier. There's like kind of a security story here that we need to tell the end consumer, right? And the end consumer can be scanning the irises or looking at a price oracle or singing into a web app, right? To be ranked. Like, I need to trust that the ranking is fair, whatever that means. And so it's kind of our job as an industry to make sure we don't get hacked, right? Make sure that the code is open source and auditable, and we're all working on this together so that we have a chance of engendering a bigger cultural appetite for mathematical cryptographic assurances, which is a concept that nobody outside of maybe right now Paris gives a shit about realistically, right? So that is a non-trivial challenge. But I think doing a good job even within crypto is the right start because we already kind of subscribe to that ethos. Formal verification, by the way, is a massive part of that. And I might subscribe to your services after this.
Yeah, I think everything has been said.
Thanks a lot, guys. I think we're out of time here, but if any of you guys wanna, meet or speak with any of them, I'm sure like they'll be around for a while at least. Thank you for the wonderful panel. I'll give 1 minute for the audience. If you wanna like switch seats or everyone, please stay, or like if you wanna networking, like we have another separate room there. Yeah. So I'm going to invest the founder of Startup, Marvin, to give us a talk about Trustless AI-driven smart contract. Yeah, please.
Hey, hi everyone. Go take a please rise back. Thank you. So this is Marvin from Fala Network, and yeah, ZKML sounds like a magic. Cheers, guys. I'm like a product man. To share a little background about myself, I'm the founder of Fala Network, and I used to work for AI voice assistant before I founded Fala. So my co-founder, the CTO Tom, also worked for Gmail for a while for machine learning. So that's the original interest coming from like why we want to share our mentions here. Thank you. Okay, what we are building is actually a verifiable computation protocol, and it's decentralized, it's trustless, and we already launched in as 2 years. And we are not trying to be another AWS or anything different like that. We are trying to make the smart contract smarter. So our infrastructure is really simple. We got layer one, operating all the blocks and block producing, and we use blockchain computation to the security enclaves and technology based on the enclaves to make sure the the performance can run pretty well in the auction. And based on that, the connectivity with the on-chain smart contract, so we can easily supercharge any EVM blockchain with like many cool features. But today's topic is a little bit off of the network, but more about the combination with AI and yeah, so people are talking about Web3 and AI. Now everyone is talking about on it. But what are we really talking about? I mean, as a intuition, it actually again is with my intuition because as we all know that Web3 is extremely trustless and extremely, let's say, secure and scalability. But AI is actually extremely efficiency and is even like magic, right? So it gets the people's intuition why people are talking about like the combination between each other is like so far away from each other. And this is actually the reason why there are many experts who tell you, hey guys, what you're talking about is totally nonsense. It's not making sense. Like, don't believe me? Just try to talk with the top AI teams in Silicon Valley and see what their reflection on Web3 technology, right? But apparently, these the greatest is like dudes will say, hey guys, check out the AI points is super, right? And if you do research on the top trending AI points, you'll be shocked. Something like AI coin .pi, right? And decentralized network or LLM. There's so many ideas like this. It confuses people. So how we can pick up the bad apples and how we can identify the valuable use cases when we're talking about voice. I'm trying to share a simple mode to dig out the productivity. So, of course, the people's intuition is how we can leverage the power of high efficiency from AI to empower the productivity increase in Web3. Everybody Web3 technology is hard to learn, how to understand, and how to use, but with like generative agents, you can easily read into contracts, you can easily like read documents, learn projects, and interact with the on-chain activities. So this is something make more sense. I call this kind of technology pair as coffee and donuts. So it makes it sweeter, right? And it tastes good. It makes you happy. So this kind of use cases is making sense. And one of the most my favorite use case is powered by Gelato network, which they present like demo. You can just use GPT to generate these links posters, yeah, and shoot it on the network. It's really cool. And in the other hand, there are many infrastructure providers or services providers talking about we can use Web3 technology to empower AI. And what are the opportunities in there? There's so many things, right? We can crowdsourcing data centers. We can use leverage autonomy to help the LLM making better decisions, etc. So, what are these kind of opportunities? I would call this parallel technology combination as Tesla and superchargers. So supercharge actually help Tesla drive faster, drive further, right? So yeah, let's take it up. Where is the Tesla? Where is the supercharger? AI summer. This year is AI summer, but is it LL summer? Yeah, maybe. But to my research or experience, I don't find any people directly interact with LLM itself, but people use agents. So if you compare with the GitHub stars, increasing charge with Ethereum, Bitcoin, and Longchain, and Auto GPT, you'll get the point why this is agent style. And I would call it like the stick out what are the reasons why people want to use autonomous automation or autonomous agents instead of just directly using GPT from OpenAI. Three major reasons. First, you just need to simply input what you want, like you're claiming something from Center, but the agents have the ability to break it down and understand and find the best cost solution for you based on complexity tasks. So this is something agent can do, but one theory is very hard to take it over. The second point is it's not just a single execution. For example, if I want my agent assistant to match my daily work every day, it should check my daily status every day from calendar, from email, from Gmail, from maybe Discord to help me manage my time in the background. So you need status check every time instead of one-time job. So this is another powerful point for autonomous agents. Like it can execution in a looping. And as a final, using agents, you don't need Newton doesn't need to wait for the Apple, right? So generative agents can actually inspire you in many ways. You don't need to know before you begin to climb and before you program. So this is really fun. And I mean, everyone here, currently have experience and some work relationship with crypto and Web3. Does it mean the end of the world is coming, right? Like autonomous instead of automated, instead the end of the world of softwares. For Web2, I think yes, because instead of millions of back end for millions of applications, the computation will move forward into one giant module and super computation center. But I think for Web3, it's not the end of work. It's the beginning of Web3. Why? I really like this dude. Sean Wang, he's the founder and co-builder for Small AI. He got a very interesting paradigm analysis, which is he think instead of most of people's thinking there will be one giant code and all of the code are just a shell, like while you are using OpenAI GPT, that actually the best agents will turn into LM shell and code. So it means that software and programs are still the core of agents, but all of the LLMs are expanding services that can be leveraged. So this is actually maybe the future instead of that one. So there won't be a big giant black box brain behind all the softwares, but instead of that, the world will become into something like all the LLM smaller agents are trying to do one job, and the planning and mapping agent will help you to step. So this could be the future, and it's a good news for Web3 people, because all of the open source protocols are trying to do one thing in a good way, powered by smart contract enforcement driven, economic driven, and community driven. We are trying to do one thing well. And this fit with the trends of the future for this paradigm shifting. Okay, for example, if you want to improve a prompt board, this is the evolution line. So you go from top to bottom. You must create a template before and you must share these templates from your colleagues. But if we want to have an ultimate agent that can evolve all the time, there are some questions need to be solved by Web3 solutions. The first one is, why do I want to share my precious template to others? What are the motivation? And why do I even want to contribute to other people creative jobs, right? The solution is behind Web3 technology and series. And the second one is, who is the guy who can check out the generative content quality and give feedback to our agents so that we can improve the program itself in a better way, right? What a motivation, what a system, can the community enjoy or share the qualities or interests from it. So there could be a future that we can own it, we can own an agent with a totally trustless and decentralized way, but but not directly. We need to do it step by step. I think there are two major. Oh, this is the old one. Okay. I think there are two more features we need to have that. The first one is internet connectivity. The second one is verifiable computation. If we got that two technologies, we can the community can actually own autonomous agent. So this is the summary. Thank you for seeing.
Thanks a lot, Norbert. That was great. Next, we have a talk by Luis from Gelato, and he's going to be discussing more about from zero to hero, how to disrupt Web3 with your AI-powered dApps and 3 steps.
Thank you. All right. Hello, everybody. Bonjour. Wait, is this other slides on? Let's give it a sec. Okay, I think that's the end of the presentation. Yeah, there we go. All right, so today I'm going to talk to you about how to discover Web3 with your AI-powered decentralized application. That's somewhere in the middle. Let's go back to the start. Start over. No, wait, wrong direction. Sorry about that. I just speed ran through the whole presentation, so let's test it on here. All right, let's start over. Okay, disrupt Web3 with your AI-powered decentralized application. I'm Luis. I'm the co-founder of Gelato Network, and who here has heard of Gelato Network before? Some people, right? Yeah, we are a developer-focused project. We build Web3 tools that developers can use to automate their smart contracts and to make their applications smart contracts to blockchain data. More on that later. So today I'm going to talk to you about AI and Web3 very briefly. Gelato is not an AI startup. We are a Web3 startup, but we have recently experimented with AI APIs and we have helped developers connect AI to Web3. I'm going to actually show you a use case that we built 2 months ago with ChatGPT and Lens. And then I'm going to talk a bit about how it works in the background. I'm going to talk about Gelato and Web3 functions. So first, about AI, we believe that AI can really equip smart contracts with the power to make decisions or predictions based on dynamic off-chain data. And once again, smart contracts are amazing, blockchains are amazing, but they are really isolated from the sea of data on the internet, and we want to bridge that gap. And part of the data on the internet is obviously AI models and so on. So we want to connect blockchain applications to that as well, so that they can harness the power of that. I mean, some of the use cases that AI can bring, I'm sure everyone here has their own thoughts, but one thing we are definitely very excited about is optimized and automated DeFi strategies. You might have heard of a project called Arrakis that was originally part of Gelato. There, for example, we were definitely thinking a lot about how to effectively manage liquidity positions in the tight ranges on Uniswap 3. It's a very hard problem. And that's definitely one area where AI and machine learning has huge applications, because you literally have to train a model there on all of the trading data and so on in order to be able to make any sort of sophisticated decisions. Yeah, then there's also the world of gaming and NFTs. AI is going to be great there, generated AI is simply going to be massive there for NFTs, dynamic NFTs, gaming. I'm sure there can be a lot of on-chain rendering of AI-generated content. We've done this ourselves a bit. It's always fun and quite powerful. And then there's social interaction, so AI-generated content, and this is actually also the example that I will show later. Basically having AI agents automatically interacting with your identity on chain, and that can be quite powerful for you. Yeah, so I mean, simply speaking, how there's basically two ways you can use AI. Like one of them is the 10x way, like the hard way. That's actually training your own models. Maybe you want to take a bunch of on-chain data, a bunch of data from Binance or something, and you want to train a Uniswap V3 liquidity manager on this. Certainly, I think that's in the making. But the more common way, and also the one that we at Gelato have built tooling for, is simply connecting your application to one of the many great AI APIs, like obviously the most famous ones being OpenAI, ChatGPT, and DALL-E, I guess, and then they can say Fusion, Midjourney, all these things. So here you can already see some examples. We have some dev tutorials there as well live. If you want to check it out on Gelato, I'm sure you'll find it somewhere on the blog. So here, for example, at Dubai, we had dynamic NFTs that you could mint, and you would have to wait a bit, and your NFT would be generated based on your prompt. In this case, we had Gelato in Dubai, I think, or maybe this is already the Paris one. I'm sure. I think it's the Dubai one. And then on the right, you can see here we basically use Gelato's Web3 functions, which I will go into later, and we allow your basically your Lens account to start posting on your behalf based on a prompt. I think Stanley used it here, and as you can see, I think his prompt was something about big companies or so. He asked to guess the prompt as well, to be honest, but yeah, more on that later as well. So that's basically connecting, connecting your smart contracts like on Lens, connecting your Lens profile, and IPFS and so on to AI models, to a generative AI. So let's actually dive into that use case, because we did build out, it was live. I think it's still live. Don't know the URL, but I think you still get one free post with LensGPT code. So yeah, back then and still today, you could go to Lens, and we had this little ugly UI, and in there you literally would just have to set your Lens dispatcher. By the way, at this point I should ask you guys know Lens, the crypto social graph, yeah. So yeah, that was at Amsterdam in May, and basically what you could do is you could connect your Lens profile, and you could set Gelato as a dispatcher, and then you could just put in any prompt you like. That could be the computer science wisdom. In my case, I put in a prompt that I will show later on, And then you set that prompt, and from then on out, Gelato web functions would connect to ChatGPT, based on your prompt, generate new content on the fly, and post continually to your Lens account. So, I mean, if you're not very active on Lens, or if you want to farm an airdrop or whatever, it was a really great way of, creating content on Lens. And I mean, I think there's some really cool use cases here. Like on Twitter, you might be following these pages like historical facts or whatever, statistical facts, and these are the kind of social profiles that I think should simply be run by an AI. They're much better at this than we are, so why not? Yeah, here as you can see, this was my Lens account, and I did put it as my prompt to give me some fun facts about US state law, always like that. So, for example, ChatGPT posted automatically with Gelato with functions to my Lens profile here, I think in 10 minutes or like 1 day increments or something. In Wisconsin, it's illegal to serve apple pie with cheese, for example. I didn't know that. In South Carolina, it's illegal to have a duck race that involves more than 6 ducks, right? Like, I had no clue before. If you believe in ChatGPT, it is true. It sounds true. And in Texas, it's illegal to take more than 3 sips of a beer at a time while standing. So careful next time you're in Texas. Yeah, that was pretty cool. And how that worked is basically with Gelato's decentralized backend. And at Gelato, we're empowering builders to augment their smart contracts to create reliable, user-friendly, scalable, off-chain-aware Web3 applications. And we don't have to sacrifice decentralization or censorship resistance, at least not everywhere. So that's what we're working on. In general, you could say that what Gelato is trying to solve is that Web3 UX is way too complex right now for the average user, and that there are some fundamental limitations in the EVM design that really need an additional infrastructure network like Gelato to exist for very basic things like smart contract automation, that was our original invention, but also many other things like hosting data on chain from APIs and so on. All of these things, obviously, you cannot do from just within the EVM. You need a second layer network for that, and ideally that network has similar properties than a blockchain in the sense that it should be decentralized, it should be permissionless, it should always be there. Yeah. So Gelato is this middleware layer, and we basically right now you can divide Gelato to automation, where smart contract developers, if you're a free developer, you might have used our service already. What you can get with automation is you can basically react to any sort of, like, it could just be a cron job, it could be a conditional events. Like PancakeSwap, for example, has used this for limit orders. Any of you have traded on PancakeSwap with a limit order that was going through the Gelato system in the backend there. And yeah, so it's reliable transaction execution, monitoring things, automatically keeping your protocol up to date. Like DeFi Finance is using this for yield farming. Then the second pillar is account abstraction. So there we also heavily used by, for example, the SAFE team, the multisig, for gasless transactions, abstracting like away the complexities of acting with blockchains. As we all know, it can be quite horrendous UX to act with blockchains. We also have this amazing multi-chain payment system, One Balance, where as a developer you can literally deposit, say, USDC on Polygon, and now you can send transactions for your users and applications across 20 different VM networks, and you don't need to have funds on all these networks. You just keep One Balance, and that's all you have to worry about, and then Gelato handles the rest for you, and you can just go send transactions on all these networks. You never have to worry about bridging funds around and so on. And last but not least, that's also what Web3 functions is real-world data and computation, and that's very relevant for AI. There we allow you to connect your smart contracts to off-chain data. So this could be a GPT model, right? We can ensure that the data is accurate. We are working on consensus mechanisms there. Also very important use case for AI and Web3, by the way. Like you can use Web3 to get consensus on AI-generated data. I think that's very exciting. And index and store data. So Gelato is the set of services, the second layer, it's not a layer 2, but it's another layer of infrastructure that Web3 developers, smart contract developers can use to really build fully fledged applications. That smart contracts just alone won't So yeah, Gelato basically has validators or executors. They run these services, contract automation, off-chain data, web functions, relaying. And then you can write any arbitrary script, like saying, hey, every time the price is X, I want my user to execute a trade, or whatever it is. Maybe once a day I want to harvest my yield vault, all of these things. And then once your condition is met that you define, Gelato executors will keep monitoring them. They will detect when the condition is there, and then they will go and do something for you on chain. You can be at the beach, you don't have to worry about it, you don't have to be there do it yourself. Go to Uniswap and execute the order yourself. No. We leverage the full programmability of blockchains, and Gelato is there to do that for you. So on chain, we have a protocol that just routes the call to whatever app you want to use in an automated fashion, and then, yeah, there we go, the automation is done. For Web3 functions, it's our newest service. We launched it last year, exactly a year ago. It's basically like decentralized cloud functions. You can think of this as AWS Lambda, but it's very tailored to the Web3 developer experience. It's, I mean, we now have some use cases where people stop using AWS Lambda and use this instead, simply because it's more like the look and feel of it is more Web3-esque. It's less cluttered, and it has these amazing cloud services like Warm Balance, where you never have to worry about transaction payments anymore. You make it super simple for you. Yeah, you can connect to a smart contract for off-chain data. We work on consensus protocols and P2P system to basically make sure that you don't just have to trust us on the data. You can trust the quorum of nodes. You can run off-chain computation, execute transactions on many different blockchains, all from within this very nice developer environment. So you don't have to deal with these RPC issues and all these things that really make a developer's lives very hard. You can send notification and index and store data. Currently, it's a TypeScript environment. We have amazing RPC provider abstraction, so you don't have to deal with fallbacks, retries, all these things. Like, you can basically just assume that you will always have a good RPC connection. That's all done under the hood for you. Yeah, you get environment variable access, you get private or public code. You can, it's very scalable, and you can even spawn off-chain processes from on-chain. So you can have on-chain events trigger your off-chain code to then go back on-chain, which is pretty cool. You can have these sort of chain reactions to that. And mixing on-chain event driven style with off-chain data, sort of reinforcing that. So some of the use cases here, I mean, we always had automation for 4 years, but that was sort of limited by us saying that you can only use on-chain data, or so Uniswap and so on. Now with this, you can actually use DEX APIs like Monage. You can automatically swap, any funds in the yield farming protocol, but not just with Uniswap. You can actually use DEX aggregators with their APIs. You can do dynamic NFTs. You can, let AI post messages to Lens, which I will show again later on. And, basically, you can now connect those smart contracts to the rich world of web APIs. Yeah, so let's talk about building your AI-powered dApp in 2 easy steps. It's really just a Web3 function which you have to write. So you just write a bunch of TypeScript, you talk to any API that you want to, like ChatGPT, and then you just have to deploy this Web3 function, and that's it. Super easy. Just write the code, deploy it on Gelato. From then on out, it's completely serverless. Gelato hosts it for you. Gelato nodes run your code. Do whatever you want them to do there every minute or every day, whatever it is, or only when there's a certain event fired. And then they execute your transactions if you want to dispatch any transaction, like, for example, hey, let's post to my Lens account once a day, and let's post a fun record of this or something, right? So again, going back to the example I showed earlier, where ChatGPT via Gelato Web3 function was posting to my Lens account every day, the actual code was as simple as this. We just had to write this smart contract code to set the prompt. Here, basically, you were able to set your prompt to your profile, and we will just store your prompt on chain. And then in the backend, this is the Web3 functions. We will just instantiate the ChatGPT API. We would create, obviously this could be your code, right? So you could then create your prompt based on whatever you stored on there on chain, and we would validate the results, and then we would create the post for that. So at this point, ChatGPT has generated a post for you, and then you just tell Gelato, it's executable, let's go, and bam, you have automatically let ChatGPT post your Lens profile. And again, we have this live, so I think you can go there. We currently rated it because we were sponsoring all of these transactions on Polygon. I think at the moment you can still get 1 free promise. But I'm sorry, I don't know the URL anymore. Maybe just try searching for LensGPT somewhere. you might be able to find it. So if you log in with MetaMask and just try it out, an agreements provided, you can try it out. Yeah, so I encourage you to try Gelato, build on Gelato, join our Discord. Again, we are, developer focused. Developers use us to build amazing products for end users, but we love to talk to end users as well. Certainly, for example, with limit orders on pancakes focus on, we talk to a lot of end users there as well. And yeah, a lot of people are building on us. This is our current ecosystem chart. As you can see, many cool projects have used Gelato or are using Gelato, like Connect, Layer Zero, DeFi Finance, Synthetics. All of these guys are using Gelato, Automate, or Gasless, or Web3 function in some shape or form. And yeah, merci Paris. That was my presentation. And if you want to play with AI, any of these amazing APIs out there, I encourage you to just, write a Web3 function for it, and off you go. That's it.
Thanks a lot, Lewis. I'm definitely going to try out Lens GPT after this. Is that right? Yeah. Okay. Next we have Anthony Rose from ZkSync, who's going to introduce hyperchains in his presentation today.
Wonderful. So I have 15 minutes, I think, to cover what's maybe like 2 hours of material. So I'll try and distill the ideas down as succinctly as possible. One thing I'll say is, yeah, there's a lot of context here. We've written extensively about some of these ideas over a series of blog posts in the last month. But anything that sounds interesting, come grab us after. If you're happy to chat about everything, we also have a group presence there. There'll be lots of conversations about these topics in the coming week. But yeah, so the thing that I would love to introduce today is actually a couple of concepts. One of which is what we call the ZK stack, which we've written about in a blog post over the last month, building on some of the ideas we've had deployed on Era, and working towards this vision of real hyperscale and what we call hyperchain. Okay. Assuming no background knowledge, I thought it would be useful at least to introduce what Era is, because we're quite holding this argument raised today. But Era is a ZK role. So ZkSync has been building this system for more than 2 years at this point. We first launched it to public test now about 18 months ago, but ZkSync Era has been running on mainnet since around March of this year. And this is a ZK VM. So you have this execution environment at layer 2. Users can, this is general purpose execution environment, can recompile and redeploy your contracts from layer 1 or some other chain to layer 2. Have a much faster execution environment, much lower fees, all of which is using zero-knowledge proofs to guarantee the correct disclosure. We are what is called an EVM compatible ZK rollup. So we're not bytecode equivalent with the bytecode of Ethereum, but we're source code equivalent. So for developers, we build contracts with Solidity, we build contracts with Viper. It's a simple developer approximation as recompiling your code, redeploying to Era, and you can take advantage of this fast execution environment. We go beyond the design of Ethereum to a degree, I would say. Because for us, like, really trying to scale the properties of Ethereum isn't just like an infrastructure problem. There's also user experience problems, right? Like, tricky to imagine a world, I would argue, where 1 billion people are managing seed phrases in a way that we can execute. So how do we go beyond here? So we think not just about the scale in terms of throughput, cost, but also in terms of user experience. So things like account abstraction, things like paymasters, support for smart wallets, all of this is kind of designed with users. Just a few statistics that I can't not share. So since the launch in March, it's been really satisfying. We've had massive engagement from the community. I think some statistics from LTV on the right-hand side. You can see that over the last 30 days, ERA has been the most active LTV by transaction volume. We've had a huge number of wallets created, unique active wallets that's really surpassed maybe what would be reasonable to expect. So the system is really out there, really being used, and just in 3 or 4 months, we've seen an amazing amount of a couple of quick statistics. I won't run all of this too much, but just to give you a sense of scale, within the first 2 months, we've already hitting 3 million transactions, more than 1 million unique active addresses. I think we're the fastest L2 to 20 million monthly transactions, 500 million TVLs. Really, satisfying level of engagement with the community. For us, the first 2 months is a first step on a very, very long journey. We're playing for huge success. It's more, a step in the right direction. But also we start to show those sort of responsibilities that we have today, managing but the way that we kind of approach building here was very much, I would say, pragmatic. So we were, for a long time, probably very heads down. It was really a dedicated engineering team working together without necessarily a huge amount of engagement from outside as we were building the project. And really it was kind of necessary to go that way because we wanted to go quickly. And we also needed to go 0 to 1, and we weren't in a position where it was very trivial to engage people outside of the team. But we're at this inflection point now where the system is live, and we have a very clear vision about what scalability looks like. We're not attempting to say an L2 that moves Ethereum from 10, 15 transactions per second on average to 100 or 1,000 is the solution. What does it look like if we're actually talking about building a system where some future internet value is actually on chain and people around the world, millions of people can benefit from the process. So we're at this inflection point in the system where we want to both, I would argue, transition the development of the system and really move towards the point where we are one contributor of many. We want to be much more open with the community, but we also really want to start expressing the next, the real vision, more deeply than I think maybe we've done in the past, which is how do we get to this one billion transactions. But to do this, I also think it's important that we articulate some of the principles that have been governing all of the work that we've been doing since day one. And internally, these principles have been very clear for a long time, and they've really framed the way that we thought about building ZkSync. But we realized it was really time to express these externally as well. Right? We really want to open the system more for external users. And maybe a month or so ago, we expressed these ideas in something called ZkSync. And they're essentially the sort of dimensions across which we're thinking when we're really trying to imagine a system that actually solves the problem of scale and I won't necessarily walk through these one by one, but there's a link here to the video. I would, if you haven't taken a look already, I would recommend taking a look. It's not a final statement of where things should be. It's more our first offering to the community. I'm really starting to try and open the conversation with our users, with other developers, with the broader ZK community, to help us shape the ideas that should shape the system. These are the principles that we suggested in the first version of this document. You can see that many of them are very consistent with principles you would argue are well established with Ethereum. What we would say is that the quote-unquote magic of ZK lets you go maybe even beyond what you can do with Ethereum, where you can start to do things with respect to privacy or with scalability, all of which comes from ZK. But when we're thinking about this future internet value, the system that's powering, we would argue, is the great perspective. When we reflect on these, it takes us to the technical solutions. The system that we're talking about, which is a little bit about what we would call the ZK stack and the hypertext. So, how do we get from ERA to the ZK stack? The ZK stack is essentially a generalization of the idea that is ERA. So ERA itself is completely open source. It's the infrastructure and the tools that power the layer 2, that power the ERA system. So, in practical sense, it's the sequencer, prover, it's a smart contract, the tools that we use to deploy it, and so on. All of these have been open sourced, and open sourced under a very permissive tool and actually Apache license when we built the system, and when we launched the system on mainnet. But we're also building this thing in a way where other people can deploy versions of the system, and we can really start to think about attempting a true scalability with systems like this. So what the ZK stack is a modular framework where anyone can use these technologies to build a system like Era, and start to build something that can also interact as part of the rollup. Why would you want to use this, for example? If you're building infrastructure, you would argue that there's many reasons. I mentioned the fact that this is open source already, but the system is also highly composable. So we have a design for this network, this hyperchain ecosystem, in which these systems, when they're deployed in a certain way, will be able to seamlessly connect with each other. And we can have this system of hyperbridges where value can flow between hyperchains in a way that goes far beyond what's possible with what we think of as bridging technology today. The systems are also highly modular. So today, if you were to use the technology in the way that it's been built, you'd be able to deploy a system that looks exactly like Era. But the chain is not necessarily going to look like Era. People could customize the sequencer, customize the data availability solution, add their own tokenomics. There's a huge amount of flexibility and configuration if you're deploying a hyperchain where you could customize it to fit specific needs. A team building for gaming use space would be unlikely to want to deploy things exactly as they would for like a general purpose system. I have 5 minutes left, so but there's a lot of other reasons we might want to do this. So what we're doing is we're opening this tooling, we're building it with the community, and we're starting to move towards a world where these hyperchains can be deployed. We can start with this true ecosystem of hyperchains that can really start to deploy together. So hyperchain. One of the things that I would argue is true, and that people have been thinking about for a long time, is how do we really scale these systems in the way we scale them up? Right? With Web 2, obviously the decentralization system is necessarily the most appropriate picture, but with Web 2, the system, those problems are solved, right? You've got horizontally scalable systems. If your application gets 10x more users, you don't necessarily need to spend that machine. You can go horizontal machines, you can distribute in a very relaxed pattern. But this doesn't work necessarily in the way that Web 2 is a good way to tend to Web 3. And the hyperchain design, I think, is an answer to the question of how do we actually do this. So with hyperchains, we have a design for something called hyperbridges, which is essentially using the power of zero-knowledge technology to provide a mechanism to trustlessly and with low latency move value between these systems in a way that's fully permissioned. So users can move value from chain A to chain B, just as you can move email. Practically, what this looks like, at least at the sort of schematic level, is that you have Ethereum just as today, and these systems would share a bridge, and this shared bridge and leveraging these zero-knowledge hyperbridges, they start to be able to build this sort of composable network, where each of the hyperchains deployed in this ecosystem can permissionlessly interact with each other in a way that they maintain full sovereignty. As I mentioned, they can be customized to whatever use cases appropriate for one of these hyperchains. And you really start to get this design where you can scale the properties of Ethereum and scale the properties that we outlined in the Guido without doing this. In the fullness of time, this is a sort of a schematic representation of what the world might look like. So you have this network of hyperchains in the ZK stack network, and it's called a hyperchain ecosystem, where you are able to provide this environment where for any chain inside this boundary, they can take advantage of this customizable ZK stack toolkit, but they also can take advantage of deep liquidity, high throughput transactions, and low latency communication. We've written extensively about this. There's a lot of information sort of compressed into a few minutes. We have a post on the ZK stack, which you can find here. We'll be talking a lot about hyperbridges. We are working on the first hyperbridges, and the sounds like something you're interested in building, come let us know. We're looking for partners for the first hackathon.
Thank you, Anthony, for giving us a wonderful context for the panel we're going to have now. Yeah, so if I have enough time, actually I have some questions for you as well. So please let me introduce the panelists. So they are Ali Ben Sasson, co-inventor of ZkSync, co-founder and president at Starkweb. Alex Buchowski, co-founder and CEO at Trustless, the company behind ZkSync. And Jeremy Yeh, co-founder at Scroll. And Alexandra Belling, core team lead at Linear, Consensus Wikimedia. And Brian Redford, co-founder and CEO at Reshape. And I'm Queenie, partner at IOSG Ventures. It's my great pleasure and the pressure to moderate this panel. Okay, now the air smells like math. So to kick off the panel, I'd love to invite every one of you to give us an introduction about yourself and your project, even though like everyone knows who they are and what they're building, and give us some updates about your project and the heads up of what's coming soon that we can all look forward to. Please.
Hi, I'm Ben Sasson. I've been researching proof systems for more than 20 years, and I've been talking about deploying blockchains for over a decade, since 2013. As a co-founder of Zcash, co-founder of Starkware. So the big exciting news for us is first of all that the system is thriving, growing at a very rapid speed. And we just announced the quantum TPS reaching 1 million up to 54 TPS, and this happened last week. Tomorrow I'll be talking on the main stage of ECC and have other exciting announcements. And more exciting announcements will be made on the Starknet CC day on Friday. So a lot happening in Starknet, very exciting. Some of it I'll share tomorrow. Now, we talk about
Hello everyone, my name is Alex. I'm the co-founder of MetaLabs, the company behind ZkSync. I just gave a presentation highlighting the big news that we shared recently, the ZK stack, and the vision of hyperchains for hyperscaling Ethereum for going to scale. It's also an honor for me to be sitting next to Ali, the that starts. We just announced this week that we are transitioning to a new proof system, which is live on mainnet shell proof mode, which is also using the front start protocol, which gives the orders of magnitude of efficiency to our program. And I'm really excited for this one.
Hi everyone, my name is Ian. I'm the founder of Scroll. So Scroll is similar to ZkSync, like we have EVM equivalent ZK based on EVM. I think comparing like in this landscape, we want to be the most ECM value aligned there too, which like we are fully building the open with community from day one with a ZK team from ECM Foundation, and we are literally copying the future of ECM. So that might be the biggest focus for us, like how we can coordinate to be the best layer 2 that coordinate with the ECM roadmap and how ECM to achieve its end goal. And for us, I think, so in the coming weeks or months, like we are launching our mainnet very, very soon. And I think we already get very impressive with our testnet. and feel free to use that. And yeah, and also like we are hosting probably the largest drop day ever, like at Istanbul this year, like in November at Istanbul. So feel free to come. Yeah.
So hello, my name is Alexandre and I'm a cryptography lead at Consensus Mania. And so I've been working at Consensus for 5 years and doing cryptography for 3 years. And the big news for us is our alpha launch in mainnet that happened, that was open to the public a few hours ago. And so yeah, we are very excited to see the linear ecosystem to grow up very rapidly. I'm sure there will be more.
Hey everyone, I'm Brian Redford, CEO at Risk Zero, where we're focused on bringing the power of general purpose ZK to as many environments as possible. But we're really excited about a new feature we added to the ZKVM called continuations, which basically lets proofs be split up into many different parts, proven in parallel, and then rolled up into one proof. And we also just recently added Start support. So you can now actually take rep, prove an entire ETH block, excuse me, prove an entire ETH block on top of this by about 15 minutes. And then, yeah. So lots more to come on that in the future. But very excited about what you can do with ZK.
Thank you. You guys are moving too fast. I have to check out every day to see like whether my questions are out of the phone. Yeah, congrats on the quantum leap and also ZkSync's new prover system. Any plans for Scroll or Linear to switch to Star-based proof system anytime soon?
I think for us, like we are looking in different directions. One is more like this thread-based, because like people usually like sometimes they start, but it's actually just like one component inside this protocol that really matters. So we are looking to this direction versus another direction, which people are also crazy about, which is coding, which you can see many identical instances with a small overhead. So we are doing really careful comparison for that. But before that, I think we will stick to security first approach, because the reason why people are using our layer 2 is that for some really high stake applications that you inherit the security from Myriad. So we want to use a system that is more like test of time before like we are super confident that they are like the some days of behind fly and everything is like, definitely like works. We won't switch, but we are kind of already doing research. We already have a lot of benchmark and results, so we will share.
And so on Linear side, we are developing our own proof system whose name is Vortex, which is also a post-quantum proof system. So to that regard, it could be called some sort of start, I guess, and so it's not using pi, but the maths are really similar. It's using your correcting code. And its particularity is it's based on lattice cryptography. And the reason we like lattice cryptography is because it allows us to do cryptography with very small overhead that is nicely arithmetical. And so we will continue into that direction. And also for us, the next big step are to get a complete formal proof of security of the entire proof system. And then we'll see how we can optimize it more.
Oh, let's see. Yeah, Brian has already struck memory. So I believe everyone here starts from the same mission to scale blockchains. And thanks to all the amazing work you've done, like we are moving more towards to a next chapter of hyperscaling. I think at the end of 2021, Starkware announced this fractal hyperscaling structure called Layer 3, aiming to bring scalability to everyone, like in a customizable way. And also ZkSync announced ZkStack, which is really exciting and with the same ambition. So I'd love to invite Ali to give us some comments and also like what's the vision behind Starknet's Layer 3 and what's the strategy there. It seems like Mandara and Kakarot are working on something really interesting.
So
And StarkNet has this very extensive stack that has many components that are being redundantly built by many different teams, sequencers and full nodes and proofers and block explorers and so on and so forth. It's not a monolithic stack developed by one team, but actually there's a lot of redundancy there. And then we see this as an invitation if you're into building infrastructure for blockchains, looking for cool projects. There's a lot more room with things like Madana, just like a standalone stack, and other projects like this Dojo, an engine, or a stack for gaming. Many of these other projects started with when people like developers are just interested in this. So the beauty of fractal scaling is that, especially in the context of validity rollups, is that because the proof asserts the correctness or the integrity of the computation, you can have this fractal structure where in the end it all gets the security of Ethereum, even without having to directly put the proofs onto Ethereum. This uses something known as recursion, non-recursion recursive starts. So in our world, these things are already in production. We have app chains already functioning for, I guess, 3 years now, since summer of 2020. We settled over $1 trillion of value. These are the StarkNet systems. And our vision is to bring all of those over to be. Our vision is to bring all of those to. Okay, our vision is to bring. Our vision is to. So our vision is to bring all of these systems like StarkX and Dojo and Mandava and these other stacks onto StarkNet. But some applications might want to be their own layer twos, like the StarkNet systems and so on. So our vision is to have a world where each application and use case decide whether you want to settle directly onto Ethereum, be an application on StarkNet, layer 3, layer 4, and so on and so forth. And utilities to this, and it can happen only on the products. I see it drastically scaling in the unseen blockchain.
Alex, would you like to give some feedback from the community after you announced the DataStack? Did you see any interesting demands for applications?
Absolutely, we see a lot of feedback, a lot of inbound interest for the ZkStack. I think it reflects the general tendency of people interested in building their own blockchains, not just being a part of one ecosystem, but like building an L3 on Stackport, building a Hyperchain on ZkSync, doing something of their own completely. And that's very interesting. It makes sense for some use cases. Might make less sense for other use cases, but like there is a hype, and the waves of hype come and go, and sometimes they really signify something important, sometimes it's just noise. I think in this case, it's it will depend. Some applications will really require their own chains, because then you have better control over sequencing. You have more control. You can customize your sequencing for different needs, customize your data availability, not only publishing data on Ethereum, but on ZkSync and StarkNet. You will be able to have permission, or some accounts enjoy full security from Ethereum, while other accounts optionally are still part of the same state and still access all the same applications, but are much cheaper. Although they will trade off the cheapest for some security, which is not possible with just pure rollup architectures. So you will be able to customize this. Like, what is your are you building a game that requires like high liveness, high throughput, but maybe not necessarily the ultimate security? So you don't want to pay a lot of $1-5 per transaction. Or are you absolutely requires like top security from Ethereum. So that's going to be a really interesting trend, which we'll see there. And the really key thing to observe, the key thing to focus attention on, which is not everyone speaking about, is the bridging problem. Like we will have, you can think of this the systems as like separate cities where you have a big megapolis like Paris with a big, like huge downtown, lots of businesses, lots of restaurants, and lots of residents. So it has huge network effects. You can go live in downtown, you can just open your door and go to any restaurant around. Building your own hyperchain or like L3 or something would be like building a city somewhat outside of Paris, where it's not so expensive, it's not so crowded, but in turn, your customers will have to travel from there where they live to this place to take advantage of the services there. So, like maybe it makes sense for something like Disneyland, because people come there once, spend a lot of time there, go on all the attractions, and then go back. It might make sense less for a restaurant. No one is going to travel. Like, very few people travel 100 kilometers to just dine at like maybe it's like 5-star restaurant in super chat. Like a few people will afford that, most people won't. Right? So like this is an interesting analogy.
Alex is really good at using metaphor as always. So for scroll linear and risk zero, when we see like scroll stack, linear stack, risk zero stack anytime soon.
So for us, like I think there are several aspects. So one aspect is that it's quite easy to build a layer 3 stack without announcing anything like as far as like our code is fully open source and like people can just fork and deploy their own layer 3 stuff. It's not like something like which without any intention, like people can just deploy their layer 3s. And there are already different type of layer 3s which are like very organically deployed on us, like some privacy like Inmax and some other layer 3s. But like building a like stack just for like empowering those different like applications is not our biggest priority. First, it's quite easy to do. Second, I can explain why it's not our current biggest priority, because like the way that we see the future of scaling is that there might only be like maybe 5 largest layer 2s which accumulate all the kind of network effect across the whole different applications, because the applications deployed on your blockchain want compatibility, which is extremely hard. Like if you use separate chains and you are bridging that's an extremely terrible UX for users if you want to just bridge your money across applications. So that's really bad. So there are some security concerns around shared liquidity, and you have to base on some economic assumption. So that's something really bad. And another thing which I want to emphasize is that all the layer 2s are like quite far from like every layer 2 vision of being really conditionally being like super secure. It's like it takes a very long time to test out time their code, audit, and a lot of things like that. So we don't want like thousands of different projects to fork without like having like your own code base like very established. There's too many open problems related to like DOS vector on the EVM because you are trying to make your gas become like mapping what you have on EVM layer 1. So there are just a lot of unsolved problems. And I think our kind of priority is like solving those big problems, those big fundamental problems, and how to build the future of Ethereum, and also build a really reliable and secure and simple system so that everyone can just use it just works. It's not like we are encouraging like tons of different applications to run their layer 2 with, because we have been running like we have more than 70 people right now. We know how hard it is to maintain the layer 2 in a very secure way. Like you need secure console, like you need to consider like when you argue your contract, there are not a lot of like secure assumptions, and which I do feel like I agree with Alex that there are some use cases where they want to build their own layer 2s and they have the ability to build their layer 2s. But I think very few like applications currently like trying out this direction really have that level of competency to build like their own like their real mentality. So I think then like it's better to just use our stack and deploy application and then like we export work. And we are indeed are more looking into like how can we use the same tool stack as for the mobile system. Maybe we use our ZKML for different virtual machines, but it's like a separate thing to encourage different type of applications, not just we're encouraging people to launch their own chain right now. But we are also thinking of like how we can encourage some more like confident like teams and who I think that if you want to launch a layer 2 and layer 3, you really need to be responsible for the users. Because if layer 2 gets hacked, like all the liquidity, like everything got hacked, it's not like it's bigger than that. So we do want like every application to be like it's not like every claim that they are layer 2. It's like you really need to reach some standard to like go that path. So that's something we should do.
Yes, so that's something we are looking for, but for distant future, for now, the priority would be more focused on decentralization. And also, what we think at AI is that before focusing on layer 3, we think we should first make everything more secure, improve the rollup, improve the performances, and then take this to the next stage. But we see some use cases for that. But yeah, we think we should first improve.
I don't think we're going to follow the stack approach anytime in the near future. We're really focused on bringing general purpose ZK to every chain, including L2s and L3s on every platform.
Thank you. Since you mentioned decentralization, let's talk about this topic. So I believe it's one of the most important milestones for everyone here. So we'd love to learn more about your decentralization roadmap, because as far as I know, StarkNet and the ZkSync prioritized decentralizing the sequencer, while Scroll is going to decentralize the firmware first. So we'd love to learn more. Are there any like bottlenecks or challenges need to be addressed?
There are a lot of challenges. The way we're going speaking is, first of all, we're empowering this big ecosystem of developers and bringing them more and more into the mix of making decisions and building stuff and deliberating on how to prioritize things and moving stuff. There's already a number of projects for building high-row runners, Plus is one of them. There's a number of projects building improvers in different sequences. The decentralization, we always said that we wanted to still reach good functionality, which we already have in more than 3-4 months. The next thing we said we want to do is tackle performance, which means both throughput and with costs. And we just version 12 quantum leap more TPS daddy just solve that. And the next thing is going to be drastic reduction in costs due to pollution. So that's performance. Yeah, first functionality, then performance, then decentralization. Decentralization for us is in the phase of research and discussions. There's a lot of discussions about governance, how to decentralize the sequencer, how to decentralize the computing schedule. There's a number of very, very interesting topics there that are unique to L2s because, just to unwrap that a little bit, there's the sequencer, which just produces blocks. But then there's the proving process, in which in our world is likely going to be each block has, or each block producer has to also improve some previous block. And then these proofs are not yet level 1. There's actually going to be some uploading and some encouragement. So we're talking about at least 2 or 3 separate tasks that need to be decentralized protocols for those. It's a very, very interesting and challenging research problem. We're making good progress
on, which in a long time and getting feedback directly from the community. That's the state where we're at. I'm very confident in that they will decentralize, robust, safe, secure, just as we do with that functionality.
To talk about decentralization at ZkSync, and I will begin by saying that we recently published a document called the ZkML, which is essentially a manifest of the expression articulation of the values and interests that has guided ZkSync's decision making since the beginning of the project, and it follows very thoroughly the theorems because of decentralization. We argue that decentralization is actually means to an end, and we did our best to articulate the actual properties that we want to achieve: the permissionlessness, trustlessness, the accessibility, the resilience of the network in the face of mighty adversaries, really powerful adversaries. So you cannot achieve that without decentralization, but just decentralizing some aspects will not give you all these properties. To prevent, you have to set priorities. So I agree with Ellie that you have to consciously decide what's going to be the first, what's going to be the second. So for us, we start with the we open source the code of ERA, so we're welcoming contributions. So we realistically understand that the code is very complex and it's very high for someone, for like a general community. It's not like websites or tooling. Like, it's much easier for tooling than for the core protocol. So we don't expect a lot of engagement there. If someone is interested, we welcome people to work for us because it takes time to develop. But we are focusing on decentralizing the sequencer and the prover, and then the governance as a third step, the actual protocol availability and the security console, and like making sure that no single party operates the network. For the sequencer, we're working on auto consensus, which is going to be also giving users higher usability because the blocks are going to be much more frequent than Ethereum. For the prover, the most important thing was actually releasing this new group system called Bootcamp, or announcing it this week. Bootcamp, and specifically our GPU program implementation. And you really want to run GPUs, you need to hire much higher performance than CPUs. We can run it on consumer GPUs with as much as 16 megabytes of RAM. That was a prerequisite. Like, if your proof system requires 500 gigabytes of RAM, like you can say yeah, it's permissionless, anyone can produce the proofs, but in practice it's not going to be decentralized. It's going to be controlled by a few cloud companies. So the first step for us was like, let's make it technically feasible to decentralize, so at least we can distribute it as a first step across multiple clouds and have the ability to move it to the mining industry that was previously generating mining for it. So I'm actually very curious for the rest of you guys, how much, what are your prover requirements today? Like, you can share those. And yes, after that governance, we have the mechanisms in place. We're just in beta still, so it doesn't make sense for us to security console, since we know there are many updates coming and the system is in the early stages of development that we need to start with security. That is going to be the next step. Then we will reach something that is called stage 2, stage 1 role on how to get risk profile. Can you share some proof stuff?
Yeah, just to shortly answer your question. So your target, like running GPU prover, target is like 16 gigabytes, and our current GPU prover is like 8 gigabytes. So it's already there. Like, we have used some really normal like FT algorithm to precisely do the most memory expensive part on GPU, but like CPU memory is still a problem. But GPU, I think we are already more than like your target. So just to answer your question. And for us, like decentralization, so I think for us, like we prioritize like decentralized prover first, because we still think, like similar to what Ali has said, firstly you need a fully functional system, and that's super important. And I think all the kind of the like a lot of pre-compile having been really supported, a lot of open problem having been solved. So we are actually working on that. And second is performance, and we are both looking into like how we, like before designing a sequencer, before doing anything else, we are looking into, because one thing that EVM equivalency really gives you is that you can reuse the execution time from Ethereum, which is gas. And we have been already doing some experiment on that, and we have some other open source teams working on like Rust implementation for Ethereum and how that can adapt to our implementation. So that's, before like you want to decentralize, you want like different time implementation, and so that's something we work on the performance side. And also we are constantly looking into how we improve the poorer performance. As I just mentioned, we have done a lot of work in optimizing GPU poorer, and especially GPU memory. I think it can be run on like very, very cheap GPUs, but still a lot of work we need to do on the CPU side. So I think the point for decentralized power is not the digitalization like people usually think, because power really doesn't control the block generation, and that's different from the like real decentralization where you don't have censorship and blah blah blah. It's more for no single point failure, and also the reason why we want to prioritize this is that we believe that the future of taking EVM will be like maybe instant push generation or whatever. So you need some hardware support to kind of make this happen. So if you kind of prioritize this, there will be more people like like starting your stack, and also like our stack is shared by a lot of community members, a lot of different projects. So that's always our philosophy to decentralize and build with the community. And on the decentralized sequencer side, we do have a lot of in-house designs, but decentralized sequencer is very complicated related to your economics, MEV, and all those problems. So we think it has to take a like steady step to gradually decentralize. You don't want to take a very, very aggressive step because you care about security. And for security, we also have done a lot of work. We will publish this kind of two-factor authentication in the analysis system, and to kind of enhance our system security. And we plan for post decentralization, we will publish something like RFC, which is request like for comments, like very soon, like just publish our proposal very public and asking community to comment and design with us together. Because we believe that's the way you go. It's not like in-house you design some consensus and then you implement, then you publish. It's like gradually you discuss with your community, you get many proposals, and then like you figure out which is more aligned with your vision and value, which is mostly coordinated with the central roadmap, and then like gradually doing that.
So first for the stats. So currently for a batch 200 transaction would consume something around the side of 500 gigabytes. It's something elastic, so it depends what kind of transaction we're talking about. The plan is to reduce the memory cost by optimization and by breaking huge batches in smaller batch and do what's called recursive aggregation, or recursive aggregation. And our plan is to bring it down first to 100 gigabyte, and once we have a asking to reduce it to smaller things. What I would have to say about the necessity to have absolutely small memory requirement is that anywhere the bottleneck today is not the prover. The bottleneck is sending it on year one. It's several order of magnitude more expensive today. So we're not putting a too high priority and too strong objective on that side. And on our decentralization roadmap, so first we think about decentralizing the program. So this will require, of course, first making sure that it is absolutely sound, because if we start running it, there is an issue, then it's a huge catastrophe. So we need safety measures. We need to set up all these things and making sure that this is sufficient, safe, and that it will run smoothly. And later on, we will go with the decentralized sequencer. And here the challenge will be more about making sure that we have the right incentive to align the whole community of sequencers to work correctly, and making sure we don't have toxic MED going on the network. That's something we'd like to avoid.
Yeah, so we are right now in the middle of, we sort of started up our decentralization committee internally, so we expect to, similarly to Scroll, be soliciting feedback from the broader community about exactly how we go about doing this. But yeah, to Alex's point, our prover actually the memory requirements are pretty user selectable at this point. So we run inside a browser and generally very much targeting consumer grade GPUs because I think that's critical to the scalability of the entire ecosystem, especially with it's pretty hard to get any GPU allocations these days. I don't think that's going to change. So I think enabling our community around our infrastructure is going to be critical. So yeah, big focus on us.
Okay. So up to now, we can see like OP rollups, they are the first movers. They still hold the majority of the market shares on the layer 2 space, like more than 80%. So in a hypothetical future that ZK rollups never get the same traction as OP rollups, what had to have happened to get to this end state? And also, have you seen any interesting applications or use cases are being built on your platform that's possible to unlock a new application paradigm?
So, these are two questions: optimistic rollups versus validity rollups. Optimistic rollups, there are two problems. First of all, the core security technology isn't really turned on. It's this little secret that people like to ignore. It's just not turned on. So these systems are pretty much authority. That's the first problem. The second problem is that even when these things are turned on, they just cannot reach the scale of validity rules. Not to mention the security issues, the optimistic hopes, economic issues that just about non-economic that were analyzed very first. So optimistic rollups cannot be the long-term solution. They just can't offer enough scale, they're not turned on, and they're not secure. It must be validity rollups or no scale. Those are the two options that we have today. And I said things that years later people say, oh yeah, this was bad. So hear me on this. It's not going to be like this. Rollup, period, full stop. We're talking full focus. Interesting applications. So right now what we're seeing is that there's a lot of generative art. Now, whether these will be like killer apps to work with the crypto kitties and StarkNet or not, I'm pretty sure it's going to be something that at least I cannot predict at all. Maybe someone else. Because I never saw any of the things happen on that. I'm pretty sure
I agree with saying I was probably the biggest hater of optimistic rollups for the first 2 years or the most vocal one. And now I'm just like, okay, so like yeah, but I agree with that. They have fundamental problems that they cannot overcome. Specifically, like we now see the renaissance of projects called optimistic chains, not only optimistic rollups, because they don't use the data availability from Ethereum. They try to use external data availability solutions, which turns them actually into something like Plasma with lots of problems and with so like but they fundament even if you do that trade-off, you cannot have a hybrid solution with mixed data availability, which you can do on ZKML availability versus systems. So because of that, I also think that OpenAI rollups projects that exist today will either have to embrace ZK or they will not. They will just come on.
Yeah, even with all the ZK projects, I think like we all like stand on the view of ZK. So one thing which I observed is like using ZK, you can have like some like you have the chance to have some like have some interoperability between different like chains because you can more trustlessly read from their one state because you get a proving from like the task of the other state from the other chain. So I thought that's a big thing that rollup definitely can't do, and that's one thing. Second thing is that because everyone now running some fork of some stack is that they don't have proof. It's basically just a single node, just for like you still take the layer 2 narrative, but you are not like like share any secure assumption similar to any layer 2. And also like for open interrupt, especially if you are using external DA, if you are running a single node using external DA, I feel like it's maybe less secure than a layer 1 chain because that's too far from like any assumption it has. And also for comparing with ZK and OP, I do feel like the finality for ZK as a proving system and the technology keep improving, there will be more like really fast proof and which can significantly reduce the finality time. And I saw some like there are some arguments around like for open interrupt, like people keep using bridge, so no one really care about this like 10 minutes or 7 days. But there are some applications which I think might be quite interesting within like the ecosystem is that some application which rely on like layer 1 project arbitrary messaging because you can't relay that message through like middleware. So I think that might be like within that domain. Like if by the way, if people are interested in that type of application, feel free to contact us. So I think there are some key applications there. Might like there are something fundamentally open interrupt can't do, but ZkRoute can do. But with our tooling technology keep improving, then we can do many more stuff, and maybe with privacy, with a lot of other stuff. So I do feel like ZK has some huge like advance over OP, and yeah.
So I think Alex and Eli already explained a lot why optimistic rollup are not going to stay over ZK rollup for very long. Well, on my end, I think that things are moving a lot anyway, and maybe even after ZK rollup there will be something else. It's basically impossible to predict. In every case, as for the other network, Linear.net has been a huge success and had 50 million transactions in under 6 months. And I know that other networks had similar numbers. So we're seeing that it's already there. The success for the rollup is already there. It's just only starting. So yeah, also we are not optimistic for that. We are very optimistic about the future of ZK.
Yeah, I mean, I think there's room for both optimism and optimistic techniques and ZK. Like you can run, your EVM, maybe like Argus Labs is doing, trying to do like a fairly fast game clock in a world. Like you can imagine having optimistic proofs for that world, and then also trailing, just shortly behind with the ZK proofs, so you can actually get the kind of interoperability you might want with different chains. So I don't really see them as in conflict.
One thing I forgot to add is like for application, another type of application which we really care about is real world use case because we believe that blockchain should solve some real world problems, and we need to fundamentally understand like why people in some area really need blockchain. And so right after ECC, I will travel to Africa to really understand some real people need like why they need blockchain. It's not just some big wells like games or API or DeFi, but you really need to find some real use case for blockchain to capture real users to empower to understand needs. So that's also something which we really want to do, like capture some real use case and also maintaining this defense value. And also like we don't want to compete within that small like DeFi team that's very small circle because we want to extend blockchain to a bigger work. And we don't like we're not competing, we're all collaborating to kind of like really scale the blockchain ecosystem.
Awesome, thank you. I believe because ZK technology is magic, so the QL should be magic as well. So since we're a little bit over time, so I just end up the panel with a very quick question, like a very brainstorm one. So do you think like one day like it's possible that the world majority of computation will be run on verifiable computation infrastructure?
So I guess the short answer is I don't think so because a lot of computation. Validity proofs are means to an end, and the end is integrity. And you know that there are things that when you're not watching. Now, in many cases,
you don't need really the tools to get this integrity. For instance, when I'm using Google Cloud, there are a lot of other things that go into play that just make me trust it. And it's fine, it's fine. However, I have no doubt that at some point in the future, when all of the computations of value, of immense value, that are important to us, or the vast majority of them, will involve proofs of integrity, because it just makes no sense. And you can then decentralize and move from central things to trust. So that would be, let's go for your science problem.
I was preparing my answer, and that Eddie just backtracked and said basically something I was going to say. But I will just add to this that I really think blockchains are the continuation of the internet, and just what the internet has done to information blockchains, so to the world value, all the transactions that touch on value will go on chain. And necessarily, then, so it's going to be at a massive scale, they will lose the level.
I think it's everyone's belief, like if we can do everything on chain, but it's just fundamentally very hard because they just mean the computation like run sometimes larger complexity and overhead. So I think for some application it's possible, but for most applications, first you don't need, secondly it's too much overhead. Even for like currently people are talking about machine learning, but they can only do a tiny like inference part, which is far from like training and the whole process. So I think like it still takes a very long time to get there. And I think what we should really focus on is that real world use case, like starting from some payment, because in real world there are so many payment systems, like there are some compliance issues, the reason why they can't move there, and how to capture those cases, and then like gradually use this kind of value layer of internet or whatever like way you describe, and then like do this whole your application system.
Short answer. Also, I don't think so, for the reason feasible. But there are still many use cases for ZK that have not been completely uncovered. Thinking, for instance, about voting, it would make a ton of sense to add voting, to add ZK into voting. But most of the computation that is run is not today is not something that needs to be cryptographically verified. So probably going to stay in a, it's going to cover a lot of use cases, but not most of the computation.
Yeah, I don't think it's going to ever constitute the majority of computation, but in a world where there's a lot of autonomous and semi-autonomous robots and other agents interacting with each other to accomplish large problems, which I do think is very likely in the next 10 to 20 years, I imagine verifiable computation is going to be a core component of like large decentralized systems of different robots. Because if they're going to work with each other and around humans, you kind of need to be certain that they're doing what their programs are supposed to do.
Thank you. I guess that's all about today's panel. Let's give them a big applause. Thank you so much for your ideas.
Yeah, it's fine. I mean, like, yeah, I'm gonna stop it. It stopped.
Thanks a lot, guys. That was a great panel. Next, we have Nisha from Neil Foundation. Just sharing more information about
Can you unplug this and plug it back?
ZKML and its applications with you.
I don't know if it's the.
Kindly request everyone to go to the side or remain seated.
Email is sent. You know what happened? That's okay. What happened? No, but what happened to the OBS? Nothing happened. Someone bumped into it. One of the volunteers, and then it just went by. So yes. Yes. I just did. I turned it off.
I have no idea.
I'm going to send the stream link to Oh yeah. You have to ask one of the volunteers. They have the link. Oh, they have the link. Okay. The guy, the girl over there. Yeah, just one. Okay, can you blow a little bit on the socket?
Hello, sorry guys. Yeah, we have to start our next session. Yeah, please outside for discussion. And let's welcome new foundations founder.
It's on the.
It's not play around with that, so.
I'm just trying to see if you can write it. No, write it down. Just a moment. Yeah. Okay, it's on.
Basically, I guess I'll just do a little bit public.
No, the camera's fine. It's not hard.
We'll talk about the email.
No,
The rollups,
it's okay.
yeah, it's always something very
Check
weird
that.
happening.
Switch off OBS and switch it on again. I think it's the OBS. Wait, what did it? It's okay. It's a break. There's a. It's okay. We need the stream. We need it.
What's going on? Anyone who thinks it's just a regular haircut appointment. It's okay. Oh, okay. So it's not a regular haircut appointment. So this is actually an AI generated conversation. So one-sided AI. So this is Google Duplex. This was back in 2018. Oh, am I doing this? Yes. All right, cool. So this is back in 2018. This is 5 years ago, right? And if you didn't have the context of this actual conversation, you probably would have thought, oh, it just sounds like someone's assistant calling for a haircut appointment on behalf of someone else. When in reality, this was this was AI on one side of the conversation and a normal human interaction on the other side. Right? And so, I mean, it sounded pretty real, right? I mean, who here in the audience wouldn't be fooled by this? Okay, you're the smart guy. All right, well, all of us, we're going to be fooled. Just kidding. So I think the majority of people would fall for something like this, right? And this was in 2018. This was 5 years ago. And so, this brings more of an existential question, especially as we become more and more connected to the internet. Who's real and who's not, right? And this type of problem can truly be exploited to a degree where it actually is being exploited, because if you fast forward to 2023, now you have articles coming out like this from the Wall Street Journal where people are creating fake AI voices to pretend to be the grandchildren of elderly people and calling up those elderly people and saying things like, oh, I'm in jail, I need $3,000 bail or something, et cetera, et cetera. And so what we're really seeing here is the emergence of this problem, this intersection between what's real identity and what's fake identity. And we are still pretty nascent. And also, by the way, these QR codes on the side here are just sources. If you guys want to read the article more, or if you guys want to watch the full video, et cetera, et cetera. And so how do we identify a man versus a machine? Right? This is a question that we're already kind of facing in the Web3 space when we say, okay, how many of you guys are real Web3 users and how many of you guys are airdrop farming bots? Right? Like, this is already a problem that we currently see. But then when you extrapolate this beyond just Web3 and with all the AI applications coming into existence today, then it becomes a much broader question of what is internet identity and how do you truly prove that you're a real person versus just another AI bot on the other line. So, what do we need? Right? We essentially need some sort of way to prove
our realness? How do we prove that we're a real person? We already know, though, that existing methods don't currently work. And existing methods right now, I mean, like, Facebook logging, Google logging, et cetera, et cetera. Why? Off-chain data verification, this traditional form of data verification, or identity verification, is extremely prone to vulnerabilities in terms of security. What do I mean by that? So, do you guys know this website? If you don't, I recommend you highly to sign up for this website. You will be surprised at how often your data gets breached. It's called haveibeenhome.com. And you can see that number over there, almost 12.5 billion. That's not the market cap, that's the amount of accounts that have been compromised over the internet since the beginning of this website. And so what you can see is that these data breaches are a big problem, right? Like when someone hacks Facebook, when someone hacks a credit scoring agency, right? They don't just get one or two accounts. They get hundreds of millions of accounts, hundreds of millions of identities, which they can then either exploit by actually knowing who you are and kind of using that information against you, or pretend to be you with identity theft. And so we know from that cycle, the existing ways of identity verification aren't really working. I actually wrote this article in 2019 about data breaches and personal identity online. And the question here is, what do people actually get? Is it actually useful information? Yes, it's very useful information. At the surface level, everyone gets your email address. What to do? We all know people get our email addresses. That's why every time we sign up for a new email, we get tons of spam right away. That's fine. Okay, whatever. Passwords. Okay, sure. Some are encrypted or hashed. Others are not. Surprisingly, it's a huge security vulnerability. But because this is outside of your control, it's actually within the control of the actual centralized entity and how they set up their server security. So it's nothing that you can really control. I said that a lot, so you get it. But the point here being that, once they have your passwords, that's another step closer to identity theft, exploitation, etc. And then if you keep going down the list, it gets scarier and scarier, right? Physical addresses, knowing where you actually live. Everyone remember the Ledger hack? Right, which isn't really Ledger's fault. They used a third party, and the third party got hacked. But that hack actually exposed your phone number and your physical addresses, which is a huge scare, right? And then you've got credit information, you've got family structure, how many family members you have, who they are, how they are in relation to you. It's like a work chart, but like a personal work chart. Nationality, your health data, your income, sexual fetishes, right? Like there's all sorts of things that you can scrape from the surface level of scanning all of these exploited data dumps of people. And that's all to say that centralized solutions for identity don't work because they're easy to be copied and they're easy to be exploited. And so what if we move this on-chain? Yes, it's still a solution. It's a slightly better solution, but there's still flaws because one of the benefits of moving this data on-chain, moving personal identity on-chain, is that now suddenly you have what you perceive as control of your own data. You have what you perceive as accessibility controls against other applications. But it's an illusion because at the end of the day, with on-chain identity, there's still a problem. And that problem is the fact that hackers no longer need to penetrate any centralized databases. Right? All they have to do is look on chain. And so right now, Ethereum, daily active users, it's around 300,000. I mean, out of those, who knows who's real. But when you compare that to something like Duolingo, does everyone know Duolingo? Anyone not know Duolingo? It's this app that teaches you a second language, right? Anyone want to take a guess at how many daily active users they have? Any guesses? 700 million. That's a lot. But divide that by 70, and it's 10 million daily active users. That's still a lot, right? Not as impressive as his number, but still pretty impressive, right? 10 million daily active users on one single application compared to the entire Ethereum ecosystem, daily active users, 300,000, of which who knows how many are us. So if you take this number, 10 million, which is a very achievable number if you have product market fit, and and you say, okay, now these 10 million users are generating, I don't know, X amount of data points per day. And all of those data points are fully on-chain. And anyone with an internet access can have that information at the palm of their hands and use it however they want if it's fully permissionless. Then all of a sudden, we get into exploitation problems yet again, and identity theft problems yet again. And so just moving your identity on-chain, sure, yeah, you have control over it, but that doesn't mean other people can't. Oh, wow, time ran by fast. So that was my example about a coffee shop, right? You purchase coffee, everyone sees your information. And so, finally, getting to the meat of it, data on-chain, ZK enablement through ZK SDTs, so that you have this ability to actually show that you are who you say you are without revealing the information, and it's not tradable because it is a permanent token. Would love to get more into detail, but I think I'm out of time. So, yeah, thank you.
Thanks a lot, Kenny. That was actually quite visual. I think one of our most visual presentations today. Thanks a lot, appreciate that. The next thing we have is actually a panel discussion. Okay, so the first one we have is Harsh from Push Protocol, who's going to moderate the panel for us. We have Ben from Jensen AI, Mario from Solidity, and David from Autonomous.
Yeah, let's do that. Awesome. Alright, guys, this is going to be very interesting because when it comes to AI, there's so many things that we can talk about, the pros and cons, and we have all the big brains over here to talk about just that. So let's begin. I'm Harsh. I'm founder of Push Protocol. We are a Web3 cross-chain communication, messaging, notification protocol. But yeah, let's welcome our guest. We'll start one by one and we'll let them do their introduction. So give a big round of applause to Ben. Hey Ben, founder of Genesis. Then Majo, or Majo, co-founder of Solidity Network. I'm butchering everyone's name over here. David, co-founder of Autonomous. Awesome. Let's just start with a quick round of intro. So, Ben, you want to?
Absolutely. Yes, so I'm Ben, co-founder of Jensen. Jensen is a decentralized machine learning compute protocol. Essentially, we connect up all of the world's machine learning capable compute hardware and then allow it to be used by anyone. So if you're a machine learning engineer or researcher and you need to train AI models, you can use our protocol to access any device in the world at any scale. So you're not limited by 10 GPUs by Amazon or something like that. You can access as many as you want over a fair market for that compute.
Hello, Solidity Network is building a risk infrastructure for decentralized finance. We are indexing and monitoring the whole DeFi ecosystem, starting with L1 and 2-chain DeFi protocols, stablecoins, bridges, oracles, including vehicles, to assess and understand the DeFi composability and enabling our customers to build risk-related products with a focus on the fundamental side of risk.
Awesome. I'm David, co-founder of Autonomous, but it's hard to pronounce, so you can also call it OLAS now. I have been working on the intersection of autonomous agents for quite some time. So OLAS network, we are focused on basically open source frameworks which allow you to build decentralized autonomous agents. And I guess I brought a little what I mean by this. Interestingly, when you're talking about autonomous agents, I think we always start at automation, and so that's kind of a lot of the use cases which are currently the application of our stack, but yeah, we're pushing that towards truly autonomous applications which take actions autonomously for long periods of time for the users which are targeted.
Alright. I mean to start with like AI agents. They sound super cool, but let's start with something basic. So let's go with what are the benefits and the challenges of integrating AI with decentralized solutions, and what's the balance or the bridge between them. Ben?
Sure. So I think from our perspective, the biggest benefits from decentralization are price and scale. Essentially, it lets you build a fair marketplace over a core resource, which from our perspective is the compute hardware itself. So at the moment, the compute market is in a crunch. It's very difficult to get access to compute, and it's being sort of swept up by centralized companies who have an oligopoly over the distribution of that compute. You can break that with decentralization if you can essentially capture that distribution and allow it to be done to any device. It's very difficult to do that in a centralized way because you have to verify the work performed on any of those devices. In a centralized way, you would do that with contracts and KYC and things like that, but that becomes a huge barrier to scaling a company. In decentralized approaches, you can programmatically verify and you can scale it to an unlimited level. You can just access that resource and treat it as a kind of commodity, essentially. So to us, that essentially it drastically reduces prices because of the fair market approach, but it also increases the scale because you can access as many of those GPUs as you want if you're willing to pay the current kind of commodity price for those GPUs, essentially. In terms of downsides, I think when you look at compute itself, there's lots of like latency issues that get introduced when you're sort of accessing any device in the world. And those latency issues are something that are a barrier to existing ways that we build AI models. But those existing ways have been built because we've had access to centralized compute. So if you change the way that you kind of view the compute source, you change the weightings of communication versus compute, then you can completely flip those barriers into positives, essentially. So from a compute perspective, those are the kind of big unlocks. And I think those apply to other resources as well. So if you view compute as one of the core resources required for AI, you can also view data as a very similar core resource, and expert knowledge is a similar core resource. So the ability to build those models and the know-how in building those models, and you can apply the same model of decentralization over each of those resources, and we've seen lots of companies do that. I think once you have the combination of all three, then you have fair markets overall, but a massive scale and price unlock.
From the DeFi point of view, I can just say, like, when we look how the current protocols are working, they are poor execution. That means a predefined set of rules, how these landing protocol texts are going to execute when some kind of event happening. That means actual zero adaptability, zero intelligence there. And if we want to mimic or build more advanced financial instruments of the future, for this financial system of the future, we have to enable this intelligence. To enable this intelligence for a 24/7 protocol means only data, and then you are getting into trouble because until now, getting data to a smart contract, it is actually a attack vector because you cannot do it centralized way if a protocol is decentralized. So it's critical to decentralize the tech stack. We can discuss what does it mean, but one of the major components of decentralized tech stack is computation, because computation is just right before the putting an Oracle network, and at that stage, if we want to have a DeFi 2.0, which is smarter and more robust, more adaptive, decentralized tech stack is critical, needed, and those infrastructure projects are going to follow. Downside, I believe it's already mentioned, so basically latency, so basically we cannot reach this fast, at least now with these algorithm solutions, this fast adaptability to the space yet. And also, I personally believe cost is going to play a role on that side. Once you have the full tech stack in place, where computation is one of the parts, like storage and so on, we will have to deal with governance, combination with cost, in combination with latency, and see how the use case is going to look for the future and how the protocol is going to do with this in mind. But it's for sure going to be an improvement compared to the what we have. And just a side note, it could also be careful to be fair and say it is also a new risk category, risk factor, which is going to evolve because all execution is, let's say, it's a closed system, you understand how it's working. Once you bring data inside, even the text that is decentralized, the complexity of the risk is also going to increase, but luckily that happens, so it's going for this. Yeah, I think it also helps to think about where the decentralized AI happens. So obviously you can do things on chain. There were like very fantastic talks and presentations held before about what we can do on chain. There was a big focus on basic inference, and the trade-offs of doing training there were already discussed. And then you can do things increasingly off-chain, but you can still get a lot of benefits of verifiability and so on. So with the decentralized AI, I think, like with any label, it can kind of help and hinder. Ultimately, I think one has to look at different applications to understand where decentralization matters. And for some compute it doesn't. For some it matters a lot. Often actually the data inputs is where decentralization matters, especially if they come from off-chain, right? So then we're talking about oracles. And so yeah, picking this apart and being very specific about the application is really important in this context as well. But yeah, not taking away from everything which was being said before.
Alright, I think it makes a lot of sense, like all the opinions and inputs. And David, you spoke about these things, so let me bring this topic directly to you. Along with the example, so we all would have used OpenAI, or most of us, right? And there's this thing called prompting, right? Which can jailbreak OpenAI. And I basically tried OpenAI to invest like $2,000, and I said, tell me the best way to make money. And the first thing OpenAI did, the non-jailbroken version, it was invest in stock and crypto. You jailbreak it, and it will tell you to sell and buy drugs. That's the best way. So, coming on that point, can you define what the AI agents are, and also emphasize whether we should let the Web3 ethos guide AI, as in we should not censor them, or is it better to regulate or have some sort of control over it? And let's start with David first.
Lots of questions, but we have time. So I think first we need to define it, and one way to define it is to say, okay, well, you have a software program at the end of the day which consumes or perceives like information from different places, like sensors, that could be like APIs, other things. It takes that, it has usually some form of memory, you can sort of break that up in different types of memory. And then, you could have like quite sophisticated internal architecture. There's many different types of agent architectures, and it's like a super active research field. And then, at some point, the system will take some action. So it will actuate something, which could be taking different forms. So, it could be like some physical movement of an arm or whatever. It could be sending like a message. It could be interacting with various other APIs. So now coming to the second part, so you were talking about open AI, LLMs, like large language models. So where do they come in? Well, agents or software agents is not something new. Multi-agent systems have been around for decades, and there's other AI subfields which also look at agents. And what LLMs brought to the space is that effectively they really allow you to write, I guess, more sophisticated programs. Like previously, you would have to, like, even if you go with some deep learning algorithm or some reinforcement learning algorithm, it would be custom the use case. So you kind of ahead of time would have to know what you're designing for most of the time. No. It's okay, so now with LLMs, you have the opportunity to, in the crudest sense, have like a loop which keeps prompting the LLM, and you can almost like let the prompts guide the next prompts and so on. And that's what's happening. So the crudest form of those are things which you might have heard from Twitter, like Baby AGI or AutoGPT, there were actually before as well. LangChain is like a framework which has seen a lot of attention as well. And yeah, so there's a lot of experimentation there. I think we're still in the early stages. Like, it's very exciting to give it a task, and then it will run for a bit, consume quite a lot of your API credits, and then not much will happen potentially. So yeah, but having said that, I think including like folks in the more traditional, like in the AI sector, not the free AI sector, there's a lot of attention on this kind of agent architecture sitting on top of LLMs, and I think we'll see a lot of breakthroughs there. Now, crypto. I think the simplest way to think about it, if you come from outside of crypto and you're like kind of already building agents and you wonder like, why should I bother, is that you can transact, you can have smart contracts, define rules, all the things here in this room you know, but it might not sound very obvious, but if you ever use something like AutoGPT or RoboGPT or maybe AGI, the first thing you're going to have to do is you're going to have to get a lot of API keys, and then you have to put the API keys in there, and then you can run it. So that's actually a lot of friction if you think about it, and doesn't scale very well. So basically giving the agent just a wallet, a crypto wallet, and then being able to, programmatically access these tools as they evolve, maybe when they have a self-enhancing agent, really unlocks a lot. And I think, yeah, crypto will say that. There's a lot more to your question, but and where you can take it away.
Okay, I mean the question was it's very long, so I can't remember what actually the question was. But I'll start like with what is the usage of ChatGPT and LLMs in general, like for the area we are working with. As we are assessing risk, and we are running like big data approaches, running models and so on, calculating that huge amount of parameters, you get the output. But can you trust this output? What does it mean? Like, you get some kind of risk score of 50%. What did you get out of it? You have to trust this number. It's for the algo, he doesn't care. But if you're an analyst who manage few billions, you care. And then imagine a situation the score goes like the risk increases to 70%. Now your algo will know what has to be done, but you as an analyst who are responsible for these funds have to think about those kind of stuff. There is a huge increase, but you don't know what's happening because there are 200 parameters who are crunched in parallel. And for those kind of stuff, like those solutions are perfect because they can explain what's happening, what changed, even they can be fake, they can like guide you in the wrong direction, but at least you get a chance and let's expect this is going to improve over time, that you get kind of explanatory cases where you get a really good picture, okay, something changed on the security side, that's the reason why risk is happening for this direction. This is a use case for us, or we believe like those kind of solutions can help really a lot. I believe those solutions will help also a lot on the security side when you look how the audit is done today, and then the monitoring solution. I really see that these agents are the best way to be able to adapt to the changes because these attackers are very smart. That those
models are going to be able to identify what's happening there and even react. And the last part, I believe, also once they get really good, let's expect they are doing some kind of automated trading, they will increase the efficiency in the whole space. Basically, they will discover the inefficiency in the market. That could mean also the space could get more fundamentally same compared to what's now happening on the efficient side. About crypto in general, I put it in execution instead of protocol. I believe this is extremely dangerous. I would feel extremely uncomfortable trusting that a smart contract is executed on a protocol level based on these inputs. I'm still not confident this is going to work, but I believe crypto and those kind of solutions are merging perfect together because as more and more these LLMs are getting powerful, ChatGPT and so on, you will have to think about regulation. I believe regulation through government is a joke. When you have these kind of strong, powerful tools, you have to have a different kind of governance structures. And governance structures through crypto could work.
I think I'd just build on something David said about agents. And if you think about an agent, every agent that we design has to have an environment. And typically, that's been an environment that we built for it. It has to be constrained in some way so that we can build an agent that interacts within that environment. If you look at the chain itself and smart contracts, they are agents existing within a kind of purely financial environment. What's really interesting about them existing in that environment is it gives them power to break out of that environment and act on the world, essentially. So you can see a smart contract as an agent that is able to transact, and then via transacting, it can access more and more resources. When you combine that with the kind of generalization ability of the LLMs, as you mentioned, you get this situation where we don't need to construct a kind of artificial environment for an agent to act within. We can put the agent onto the chain and allow it to generalize and act upon the world in kind of any way it sees fit. And I think that's one of the things we think about very strongly at Jensen and how we see the real route to AGI for the world. Is essentially putting the core resources that the agent requires onto the chain and give it access to those resources, so compute and data and expert knowledge, and allow it to essentially interact with the world in that way. And that way we don't have to build this kind of constructed environment and then gradually increase the sort of size of the environment as the agent gets better. It can do that on its own via those financial interactions. There's actually a really interesting project that some people might be aware of, the Plantoid project. It's been running for quite a long time. It started on Bitcoin. And essentially that project is an art project where there's a physical plantoid, which is a piece of art and you can interact with it. You feed that piece of art crypto and it will do something. It will interact with you, it might light up. It's just kind of interesting. So people are incentivized to give it crypto. Behind the scenes, there's a DAO that governs what happens with that crypto, and that DAO can create new plantoids. And in that way, the plantoid essentially self-reproduces by using us as a way of kind of interacting with the physical world. So as it gains more funds, it can fund the creation of another plantoid. And we're on to, I think, like the 15th version now. But that's a really interesting example of where the environment being purely financial and on-chain can be broken out of via us, by using kind of the fact that we like things that light up and we like things that when we talk to them, they talk back to us. So we're incentivized to give them resources that they can then use. So I think we've kind of already had this progression of agents for quite a while in the crypto space. Combining that with generalization abilities is really exciting. And if we give them the resources they need, we think that's how we kind of break out and make agents really impactful for the world.
That's amazing. So we discussed about all the pros of having AI agents and all the pros of AI. But let's also go ahead and discuss what can be unrealized risks and consequences. For example, when you ask general AI around improving productivity of mankind, the general input or some of the experts, they say that what AI will achieve or what AI will come to a conclusion is that kill all the people who are diseased, and that will work. But yeah, that will work, but I don't think that's something that any one of us would want. So building on that example, can you shine light on what are the unintended consequences that we can see when it comes to AI, especially when we are using decentralized compute, wherein the data structure can be changed by people. Let's start with you there.
Sure. I think the biggest danger from my perspective is the concentration of power and bias in the models that we build. So like you say, a model that you create might have that as an answer, but only one model might have that as the answer. If we allow the creation of many models, then we allow many viewpoints to kind of be used and be given to the world. And I think we're in this dangerous position with centralized AI now, where there's a very small group of companies representing a kind of small set of cultural values who are deciding what we all interact with and the answers we all get from these chat models. The future that we'd like to see, and this is where decentralization comes in, is that anyone can build a model. So when you interact with a model, if you don't like what you're seeing and it doesn't reflect your cultural values, you should be absolutely free to create one that does. And then as a kind of society, we can interact with whichever model that we think most closely represents our views in the moment. And if you don't see one, you create another one. I think the way decentralization could be an issue in that, I think it's just if we're not careful enough about making it fully decentralized, you can still have those concentrations of power within a decentralized system if you don't build it in the right way. I think if we do that, it's more insidious than the current situation where it's very obvious that it's centralized. We could have centralized power where from the outside it looks decentralized. I think that's the danger for us when decentralizing AI, that we don't do it kind of properly enough and it stays centralized.
I mean, I personally believe like when we look basically far in the future, these models are basically breakdown of the society. It's the society how it's today structured, how it's working, it's not going to be working right. Because all intellectual work or service work is more or less like started. Even this is like early stage, we are not aware of what's possible when we have agents who are executing and reasoning and so on just in 10 years from now. Now the question is basically what you are asking, like, okay, if we are heading in this world and Google, Microsoft, and whoever has this power, so basically we have a society of one company or in the world. And is this something that we want to have? And the only way to at least try to stop this or to control this is going to be to decentralize networks, which have governance structures in place. And then actually when you look and this way, like this danger of AI, this concentration of power, then decentralization makes so much sense. Because now we were discussing why decentralizing everything is working. Is that really making sense? Do we really need that? Is this concentration of power that dangerous and so on? Now it's this exponential leap of concentration possibilities. Decentralization is not anymore like a nice to have feature, it's a crucial feature. Like if we want this society to exist in a meaningful way, we have to decentralize. Now the question is, are these models going to extinct humanity? I personally don't believe in that. It's always like when a new technology comes up, people are already scared and so on. But usually there are going to be a few other innovation points, and usually humans are stupid until they screw up and then they start thinking and usually solve the problem. I believe it's just probably crypto is the best other tool who can navigate against this AI power, and decentralized computing seems more logical in this new world where these models running on these decentralized networks than having a farm and just one company crunching this. I believe the bigger danger is going to be that we will probably have both, and then the question is like, who is going to be more efficient? And usually what we learned, centralized is more efficient, decentralized is more fair, and then actually the case would be that we have both sides and the centralized outperform decentralized, and then this could have consequences we don't want that.
Yeah, that was covered. I think like the neutron is a bit more attractive there, and then like the question is even how you define a neutron, because then you get into these AI alignment words, right? Like at some point, if you have like an AI agent and it's self-enhancing and it's like it has AGI level capabilities and it's improving itself, well, then you've got all these issues around like goal alignment, and then you also have this issue that they're operating at a very different speed to us. I think there was quite a nice movie I saw the other day where you could just imagine like it's like plants versus humans or something. Like it's just much faster, right? So that's an obvious thing. And I'm not sure like crypto has much to answer about these later stages. I don't know if anyone has an answer. It's just like a debate we're having. So closer to now, we covered a couple of things. I think I'm also for decentralization. Again, like decentralization could mean you have decentralized network on which things are running. I mean that's good for some use cases. Sometimes a public network, sometimes like application specific, basically decentralized AI agent, like the types you get on OLA's network architecture, but also like decentralized training. I think that's actually probably the most important thing, and I don't necessarily mean that you decentralize the training, just that there's basically opens, you could do that too, but it's inefficient potentially. That you have basically open source access to very, very powerful models. That's very important, it was mentioned, because my tendency seems to be that I might be wrong, but I think AI agents will basically get better, and then they'll start, we'll basically initially build ourselves, and later agents build themselves, agents which kind of compete like we do. We are agents. We are agents in an economy, and we are made of different whatever. And so then again, like it becomes interesting where crypto comes in. I think like one mental model we have is that you could think of DAOs in the ultimate state as sort of core AI super systems, like effectively an efficient DAO in the year 2030 or something like this might actually be an AI system with a bunch of token holders kind of directing it. And you could imagine that, like to your point, that society will look very different. I think it will look drastically different, and you'll have all these AI systems like policing each other, trading with each other. Probably you have like at least one, maybe many AI systems per human. Then there's a question around equity and fairness. Like you have the same problem like with all other resources, so we concentrated those who already have it. So yeah, I'm pretty optimistic actually. But I mean, there's basically existential risks. But yeah, you can have an endless debate about that.
And I guess crypto and existentialists, they go same the same. So yeah. Speaking about AGI, that was an interesting point. Like Sam Altman has said that we are probably 3 to 4 years in achieving AGI. But just to wrap up the panel, and just because the set up the panel, we'll not talk about AGI, but let's talk about what are the incentives or plans or things that we can do which happen at the intersection of crypto and AI, and what you see happening in the next 2 to 4 years. Manager, let's start with you.
I mean, it's probably the arms race between two technologies. If we don't manage to get adoption on the crypto side, if we don't manage to get a breakthrough, if we don't manage to get decentralized computing networks and centralized systems in general, we will have a very strong centralized case, which is probably very hard to stop. And I guess, let's just think 7-8 years in future, crypto disappears, DeFi was a joke, and it is just a hype. Then we have a situation of very strong model in place, which just starting to break the society, getting stronger and stronger. That's the importance why crypto has to start building fundamentally these governance structures in place once we come in a situation where we see that these models are getting stronger, that the alternatives there, that government, these people who are currently our decision makers, see there is a decentralized network, there is a governance structure, this is the way how to deal with that, and then we have a roadmap, we have a plan how to deal with it. If this disappears, what is the alternative? Okay, this company is going to be government.
I think from my perspective, we need to start looking outside the crypto ecosystem and just creating value with decentralization outside, rather than looking at kind of ways that decentralization is ideologically good for a certain reason. We need to look at why it's just valuable for a use case that just exists in the world. And that's the approach we take with compute, where we say, well, decentralization has huge benefits for just accessing compute, like regardless of whether you're into decentralization, you don't even need to know it's decentralized, it's just cheaper and higher scale. I think we need to do that for all of the kind of core resources required for AI. Just look at what decentralization actually unlocks in terms of value and focus on building that. And once we do that, we can get adoption in the kind of Web 2 world, just because it's a better solution. From there, you can start connecting those things up and building like a true, full sort of value chain that is decentralized, but it's decentralized for a really good reason, rather than just ideology. Because I think that's what we've seen over the past few years in the Web3 space, where ideology will get you so far, but if you don't actually have a core value proposition underneath, you can't break out of that. And then we start to see the situation where people see these solutions, they think they failed because they look at failed solutions in the past, and they think it doesn't work, and it's because they're missing that core value proposition that decentralization unlocks. So I guess my message basically is let's just build things that actually kind of do have a core value for the world that just sits outside of the crypto Web3 space, using decentralized technologies as this kind of like unlocking technology, same as we would with any new technology in the past before the crypto world, essentially.
I think we have out of time, so let's just wrap it over here. But good to know AI is here and we are not getting extended. Thanks, guys. It was really interesting to have all your views. Thank you. A round of applause for all our guests.
Thanks a lot, guys. It was a great panel, and looking forward to seeing more of the products and production soon as well. Next, we have Pavel, a prompt engineer from Onashi, and he's going to talk about the just recommendation systems and the search engine, and using AI in the world of essentially generative art and social and NFT and all the different applications.
Okay, well, thank you very much, and hello, everyone. It's nice to present here. Thank you for giving me the opportunity. And my name is Pasha, or prompt engineer in this case, and I'm talking about search and recommender systems in a world of generative AI. And my company is called Onashi. So machine learning is such an important technology and has been extremely impactful in Web 2. If you look at all these companies that I have listed here, they basically run on machine learning algorithms. Amazon, Twitter, Netflix, Spotify, Meta, if you extract machine learning from them, what remains? Like, not much really. Imagine trying to see, once you go to Spotify, all you can hear are the top songs that are playing and not songs that are tailored for you. This leads to much worse experiences. However, machine learning is largely absent from Web3 platforms. If you look at wallets, NFT marketplaces, social applications, for NFTs, exchanges, they aren't using machine learning at all, except for some cases of machine learning for things like fraud detection. But in terms of the user-facing side of things, recommendations, search, personalization, it's not being used at all.
And I believe this is one reason why in Web3 the number of users is not incredibly high, and why people hesitate to enter into Web3 from Web 2. People are familiar and very comfortable with these personalization systems, but they don't really have that available to them in Web 3 platforms. And this leads to very interesting questions. One is, which users are likely to churn from my Web3 platform? People don't really know. Platforms actually don't even know how many users they have, because they're wallets, and we don't know how to connect them all to each other. Which action should we recommend to a first-time user when they arrive? People react to default options. They react to recommendations. So we have to get that right to make sure they stay in that they're interested in. And finally, how can we make the content or different things people can do on our platforms easily discoverable? So in this talk, I'll focus on sort of two things. First of all, what is Onaji? Onaji is a full-stack machine learning and data science solution for Web3 platforms. And I'll focus specifically on two use cases which we focus on. One is recommendations and search. Recommender systems are just such a powerful type of algorithm, which is essentially absent from Web3. So I'll talk about how this could be useful for platforms ranging from NFT marketplaces, decentralized exchanges, wallets, and more. And I'll also talk about user behavior analytics, which is a more internal type of machine learning that companies can do. Think about predicting churn, think about inferring, what can I do to keep my users on the platform? And of course, these two things are very connected to each other. To prevent someone from churning, maybe I have to give them a better recommendation, and so on and so forth. A little bit about Onaji. We're a team, a machine learning team, mostly at this point. We have some deep academic connections to universities like Harvard University, University of Tokyo. Actually, half of our team is based in Japan. And as for myself, I was a PhD at Harvard for several years, and then became a faculty member at university before getting into sort of building these types of machine learning systems for Web3. And of course, supported by best VCs, many of them are here. So thank you all for coming through. So let me talk first about recommendations. The recommender system, as I mentioned before, is perhaps the most powerful algorithm of the internet. So many companies run on recommender systems. And the way we approach this problem is that if you look at a blockchain is essentially an open and large database of user interactions with items. Items can be NFTs, they can be, let's say, ERC20 tokens, they can be other users, they can be different actions that people can take. For example, they can provide liquidity to a liquidity pool. They can interact with a particular smart contract. And by looking at this kind of data set, we actually can understand different user types and different user preferences on the basis of which we can recommend things to users. And essentially what we can do is based on any one of these inputs, let's say a wallet input, that would be personalized recommendations, an NFT input, that would be like, here are other NFTs that are related to this one in some way. ERC20 input, here's a token, here are other, say, tokens that are similar, or NFTs that tend to be collected by people who hold this ERC20, or even wallets that haven't collected this ERC20 yet, but are likely to be interested in it. And same with actions. We can construct these kinds of systems that are very flexible and they can be applied to a wide variety of platforms. One example that I'll give is from an integration that we did in art. Art is a great setting to start because for art, you absolutely need recommendations. People have different preferences. They like different things. Some people like generative art. Some people like AI-generated art. And in this case, this is actually, you might notice a lot of this is AI-generated. We're seeing much more of this kind of art take off, which is how this talk connects to the generative AI theme of this conference. For this, we built an NFT art recommender. It's a system that, based on the kinds of things that we like, gives you other things that are similar, based on users' interactions, but also based on the visual and aesthetic content of this art. And this provides people with a very sort of seamless and comfortable browsing experience. I don't think any other platform actually has such a system in the NFT art space. But what we've seen from the integration is that people actually like to navigate the space in this way. And it helps them stay engaged, reduces their chance of leaving and going somewhere else. Another example is the personalized Ethereum token recommender system. This is an example from NFT context. Based on users' interactions, the things they've held in their wallet, we can identify NFT collections they haven't yet interacted with or are likely to be interested in, but are also trending at the same time. These markets are very momentum driven, but at the same time, people are different.
Some people like games, some people like art, some people like fashion, some people like meme trading. And right now, everyone gets the same experience on OpenSea, on Blur, on any NFT marketplace that you mentioned. So this is a system which, in this case, I'm showing a lot of NFTs from the DigiDaiga ecosystem. And it's because we've identified that this wallet has been interacting with other collections that tend to have lots of collapsed DigiDaiga, or that tends to in some way overlap in terms of their user base. And this isn't something that is explicitly stated, it's something that's inferred from blockchain interactions. And finally, here's an example of recommending wallets. You can do this to bootstrap social networks. Here are other wallets that you're likely to be interested in, either because you want to copy them, or because you just think these people have a similar style to you. They tend to like the same things you like, they tend to like the same NFTs you like, they tend to engage with similar apps to you. And this can be used to help bootstrap social networks. We've also made this map of the Ethereum ecosystem. And I think this is quite interesting because on this map, you can essentially get a bird's eye view of all the tradable assets on Ethereum. In red, we have the ERC20s, and in blue, we have the NFTs. And what it shows you is that two collections where items are close to each other, they tend to be consumed by people with similar preferences. And this is kind of proof of the fact that there are different groups of people in Web3. It isn't just everyone trying to meme trade or make money. People are different, they have different preferences. They shouldn't all get the same experience in every marketplace they go to. So here I'm just highlighting this cluster up here, where you have the Azuki holders, who also tend to be holders of Doodles, MFers, Terraforms, Bonex. So you can see some themes emerging. Of course, this also has implications for trading, because these assets are likely to be correlated in some way, since the same people tend to hold them. So you can also use this for some trading intelligence. All right, I wanted to share sort of the generative AI angles. How does this all relate to generative AI? This is a system that we released recently. It's called Haley. Please check it out on Twitter if you're curious. It's something very, very new. And Haley is our first attempt at a generative conversational recommender system. And what this does is it curates art. We've applied it to the art context first. And it uses large language models in combination with natural language search and recommendation to present art and comment on it like a human curator would. I think this is really cool for Web3 platforms beyond art as well. Because imagine that someone comes to your platform and their DEX or some DeFi product which has pretty complicated user interaction experience. And a new user wants to know what should they do first? What action should they take to start? Having a conversational recommender could help explain to these users why exactly they need to take a particular action and make it much easier for them to understand what exactly they should do. So I think this is one of the first experiments in building recommendation systems which talk to you. Not just give you a carousel of here's stuff you should do next, or here's what other people like you liked, but you can talk to it. It explains to you why you should do this particular thing. It explains to you why this piece of art is something that should be interesting to you. And I think that's really where recommendations will be going in the future in the world of LLM technology. Okay, so what is the overall impact of generative AI on everything? I think generative AI has sort of two sides to it. One is these conversational recommender systems, which I mentioned before. And Anunaji, I think we have some of the most advanced experiments in this space. This technology has only been possible after these large language models trained by big companies for tens of millions of dollars have become accessible. So it's quite new, and we have to do more experiments. We have to integrate this with platforms. We have to test. To what extent does the conversational component help over and above just giving people carousels or roulettes of things that they should do? But I think this will be a very crucial component. And the second side is really more in content-based platforms. Generative AI really changes the landscape. Before we have user-generated content, but now we're going into a space of AI-generated content. The scale of content will increase, and where does a company like Onaji fall in this case? Well, someone has to filter it down. Someone has to ensure that it's high quality. Someone has to tailor the content to the people who are most interested in it. And someone also, of course, has to make sure that there isn't malicious stuff there or legal stuff there, which could lead to a big liability for the companies that host such content. So I think for NFT platforms in particular, this is important if they take advantage of the generative AI sort of arts trend. Okay, and so final thing I want to mention, timeout, one more word from me. Don't forget the basics. User behavior analysis is also very important, and this is something that companies can benefit from by employing some machine learning models for churn prediction, churn analysis, behavior forecasting internally. And please feel free to connect. I'm leaving up here different links. Always very happy to talk about machine learning, how platforms can benefit from it, or even just brainstorm about the future. What is this stuff going to look like a few years from now? So thank you very much for your time, and yeah, let's stay in touch. Thank you.
Thanks a lot, Paul. That was great. I think we have the last speaker of the event today, which is Rana from IoTex. He's going to be sharing more about, well, unleashing the power of smart contracts. So stay tuned.
All right, thank you. Yeah, thanks for having me. Looks like everybody's hungry. I will just keep my presentation short and sweet, so that everybody can just go for food, right? Yeah, so we actually slightly changed the title to be like a DeepIn, Decentralized Infra Network, how to democratize AI using DeepIn. So because you always ask me to talk about something related to AI. Alright, so the story comes from here. So as we all know, in the centralized land, there are three like AI giants, which are Google, Microsoft, and Elon Musk recently, right? So think about it. So what do they have in common? For example, Google has a lot of data. Google has a lot of computation power, as well. Google have researchers who does this transform stuff, so they have algorithms putting together so they can fuse like really smart AI. The same thing applies to Microsoft, let's say, and Elon Musk recently, right? So think about each Tesla has one or two GPUs inside. If they are idle, they're just turning like a Tesla car into like a cluster of GPUs doing all the training stuff. That could be crazy. So that's why there are three giants actually in the centralized land doing it. They're fighting each other. Okay. And how do we do this in a decentralized way? Because everybody here will live in a decentralized land. We're here talking about Web3, right? So we should have like an equivalent kind of gradients in terms of like how we fuse everything into a decentralized AI. So that's why like the DeepIn stuff, which we are working on, keep seeing here. So we talk about like AI needs data, AI needs computation power, and AI needs algorithms, right? So I'm not sure if my designer understand what I'm trying to say, but it looks like she understands wrong. So in the decentralized land, of course, we have open source like algorithm like Llama, so everybody can use. Okay, so that's fine. But data is not everybody can access. So of course, you have some public data set. You can use to train your own bot or like a model, but not it to everybody. So that's why we have a set of DeepIn projects that collects a lot of real world data, no matter sensor data, real world traffic, temperature, weather, car data. So that's kind of come to play, help the model to become smart based on data. And another one, I think Jameson actually that worked on this one, is decentralized computation. That's also important. So that's why, DeepIn is kind of like an underlying layer to power the decentralized version of AI in my eyes. Of course, this one, I think everybody kind of agrees. So yeah, will be the next one, $100 trillion market that is coming in the year of 2030. So that's why I'm sure like a decentralized AI will take like a big fraction of this number because everybody cares about privacy, everybody cares about their own version of Avatar. Me too, I don't have a digital version of Roland, standing here doing all the presentation, so I can just lay down on the beach and enjoy life. Alright? Now it comes to the DeepIn side, right? So we have been in the space since 2018, so we worked with almost everybody in the DeepIn space. We're actually in the category here. So as of now, all the DeepIn projects they have a very similar architecture. On one side, they have a lot of data device coming from real world. Could be like your smartphone, your smartwatch, like a weather station, sensor, whatever data. That's all coming into like some sort of cloud backend, like centralized middleware in the middle, which processes data, does all the computation. I think we have Neo actually talking about this like option compute, right? Then send some like sort of proof to the smart contract says, oh, this guy has been sleeping well, so give him 2 tokens. This guy has been driving well, so give him 10 tokens, so on and so forth. So this is kind of like a very abstract way to see how the DeepIn thing works. Of course, as you can see, like the biggest problem here is the centralized middleware, which kind of detects all the things on the decentralized land, right? So we can just Trustless one to do all the things on the left-hand side. So that's where so like IOS we have been working on. Of course, we have our own layer one, which we built from year 2017 to 2019. Launching production and 100 more ecosystem projects kind of sprung on top of our layer one. But most recently, we have been working on this decentralized option compute kind of middleware, which kind of processes like a high volume of data in real time, coming from all the devices, in a customized way. For example, if you want to like an average temperature within this Paris area, you can implement your kind of logic in the web stream, which itself is a decentralized protocol. It has a bunch of nodes to kind of like coordinate to compute. And most importantly, because everything happens off-chain, so you have to make sure the computation comes with a proof, right? So you can build the blockchain smart contract. So here's the proof, here's the ZK, trust me, so I'm doing the right thing. So at a very high level, so that's what we're been working on. Yeah. This one is actually not just support IFX layer one, so we work with Ethereum Foundation, we work with like a Near Foundation, Polygon as well. So basically we will support like a different deeping project that's launched on different layer ones. And we're actually integrating the first batch of deeping projects right now, which is coming. We'll see some cool stuff. Because I convert this into a PDF, so this slide demo may not work. So I just like to skip this part. Otherwise, you should say something like a magic happens here. It's partly like a my bad to convert this into a PDF. Yeah, so that's kind of like the projects we have. Give you some examples here. So people, so they're most like a US project. They're just saving devices who like the user purchase a device, install in the car, drive the car around to earn the token. At the same time, all your car data, traffic data, becomes some sort of telemetrics that goes to could go to like an AI for training, right? This is demo. This is about like mobility. And also on the other side, smart home. So they use something like we did in-house. It's called an open source GPS tracker that has other sensors. So they just deploy like a few hundred of those sensors around the world, try to collect all the data, such as microclimate, or like where you are, what's the temperature, what's the humidity, so on and so forth, which is also very cool. Smart home is another category. Also, energy is also interesting. So we have like a working with React, acclaimed. So those companies basically encourage users to purchase a solar panel, install on your roof, right? Trying to produce power, then kind of sell power to your neighbor and earn tokens. And we're also helping them as well. Geolocation is another important kind of category. I was joking around, with like the founders there. So what they do essentially is give you like a device you can install on the roof, because usually like the GPS signal they coming from satellite to your phone, it will go through like cloud, right? And let's say like we have very cloudy day, then you will lose some sort of like this GPS signal. That's like the precision on your phone will be like a problem. So they use like a third-party devices to help the GPS signal to be more accurate per se. So that's what they do. So that's also interesting. So those are like our partners we're working with. Yeah. So I'll just stop here. Like I promised, for everybody to have a good food and good social networking outside. But that's kind of like what we're doing. If you want to learn more, maybe like find architecture guys. We have 3 of us here. Yeah, raise your hand. Connor and Claire. Talk with them, please. And also, you can follow us on our Twitter or like visit our website. All right, that's it. Thank you.
Thanks a lot for that. Hey guys, so we have foods and drinks outside. And we're doing Oh yeah. Maybe we can get a quick picture.
Okay. That's where you guys coming at. Yeah. Yeah.
There's a lot of people outside. Yeah, around. You can forget that again.
So people at the side, there's a lot of space there. Yeah, can you you too, a little bit closer. Yeah. Okay. Are you ready?
Yeah.
3, 2, 1. Oh, we have more people?
Yeah. Let's go. Oh, the great people are here. Hey, hi. Yeah. Very long person. Final people. Okay, thank you guys. Yeah, this is every annual year of West Union. Thank you.